All right, good afternoon, everyone. Participants joining us across the globe. You are once again welcome to the revision class organized by the Mathematical Association of Nigeria, Ogun State Chapter. And of course, this is the way we normally do it every year. But this year, we really want to appreciate those people that have been behind the program of today, especially the Toide online class and other content creators that have been on our neck that, oh, we must make sure we organize the revision class for our students. And we want to appreciate all of you for the support and the encouragement. We especially want to appreciate the state chairperson of the Mathematical Association of Nigeria in person of Pastor Bemisola Orekoya. Since she has assumed office, she has always been on her neck that there is a program we normally do every year for our students that are writing SSC, and which is the virtual revision, because we know we may likely not get every student gathered in a particular center to be doing revision for you as an association. And that is why we decided to bring this online. So we have many people, many content creators, let me say seasoned mathematician. They are here online with us. They'll be taking us through the revision. And of course, this is going to be in another form. Before, it used to be, we used to start from one topic to another. This time around, we'll just pick some of those specific topics from our past SSC question. We show you how you can answer them, and then those strategies you need to do to manage your time on each question. And like I said, we have seasoned mathematics educators with us, and in the studio with us, I have Oladele Ogunfowote, who is the founder of Toidel Online Class. We are still expecting the same Nofu Shidedube to join us. That's the founders of the same Nofu online math class. We are also expecting Tamboa to also join us from the northern part of the country. We are looking forward to see others math teacher who has promised to join us in this revision class. And we hope what we are doing will definitely reflect in your performance by the time the result is out, let's say by God's grace, in September this year. So I'm going to hand over the mic to the founder of Toidel Online Class. He's going to lead the class while others math teacher will also join us in doing the revision. Or please, if you are here with us, can you just let us know? Can you introduce yourself? Let us know where you are joining us, the state where you are joining us from, possibly your local government. Let us know from the chat box. We can see a lot of people. Quite not. I can see Dorcas Hassan saying good evening, sir. I can see Amadi saying I'm ready for the virtual revision class. I can also see Sunday saying ready. Tony Akonbi, Ike is also joining us. Taiwo Victoria joining us. Nofisat joining us. Taiwo Victoria joining us. We have Ifonio joining us. Adeyemi also joining us. Shide Dube also joining us. Taufik also joining us. Michael joining us. Rachel joining us. Paulinas joining us. Esther, Chiamaka, they are also joining us in this revision class. So we are still waiting for the state chairperson of the Mathematical Association of Nigeria. But without wasting much of our time, because of our students that have been online since, we would like to go on now to start with the revision class. If the state chairperson join us, we also take a goodwill message just to charge us for the tax that is ahead of us. Yes, I can see Afolabi joining us from Ijebu North local government. Thank you. Tajudeen Ayomide joining us. I can see Chiamaka joining us from Enugu State. Adedayo, Abolore, Aaron, Daniel. They are okay. Daniel is joining us from Ondo State. Thank you, Daniel. Adeko also joining us. I can see I am Dosumu Joseph joining us from Alaro Community High School, Ogun State. Thank you. Paulina joining us from Adamawa. Taufik is joining us from Ogun State. You are all welcome, and we wish all of you best of luck. Like we said, this is just to prepare you for the task that is ahead of you. We are not creating any fears in you. We are just trying to tell you you can do it. And with what we are doing this evening, we know that the outcome of the mathematics examination tomorrow will definitely be fine. And then we also build that kind of confidence in you. And everything you need to do in the exam, we will definitely tell you here. We have no any other thing to support you than to use this kind of a platform to support you as our student. So thank you, Ayola, joining us from Ogun State. Taufik is also joining us from Ogun State. So on this note, I want to welcome the founder of Toydem online class, that's Oladide Bufowote, who will start the class with us now. Over to you, sir.
Thank you, sir.
Thank you, sir.
So, good day,
Good day
viewers from all over the
from
country.
the country.
We are welcome to the revision
The
class.
revision class.
So, in order not to waste
In
our
order not to
time,
waste our time,
I would like to start
I'd like to
the
start
revision
the revision
from number-based
from
system.
number-based system.
So, we're going to pick one or two questions. Once I pick a particular question, solve to give you.
Then I'll use the opportunity.
So, I'm going to give you. Let's start with number-based.
I'm going to give you
Number-based system.
opportunity.
Let's start with number-based system. Let's start with number-based system. So under number-based system, of course, we are familiar. I want to believe that we are familiar with this number-based system.
Let's start with number-based. We are
So under this number-based system, I want to believe that we are familiar with this number-based system. We are familiar with this number-based system. What's going on? Hello, am I audible? Hello? So am I audible? Okay. Under the number-based system, we normally convert from base 2 to base 10, then from another base, from base 10 to any other base, then from base 2, base 3, base 4 to any other base. So for instance, if you pick a particular example now, This example says that we should convert 35 base 10 to a number in base 2. So if you have to do this now, we have to convert this to a number in base 2. So if you have to do this now, what we normally do, as we all know, what we normally do here is that if you want to convert to any base, from base 10 to any base, this is base 10. We are going to use that base to divide. For instance, when we have 35, since we are converting 35 base 10 to base 2, we are going to use 2 to divide all through. So how many times will 2 divide 35? That is 17. We write out the remainder 1. That's what we are going to do. We write out the remainder. Then how many times will 2 divide 17? That is 8. Remainder 1. How many times will 2 divide 8? That is 4. Remainder 0. How many times will 2 divide 4? 2. Remainder 0. How many times will 2 divide 2? 1. Remainder 0. Then of course 2 cannot divide this, so the remainder here will be 1. So if we don't want to write out the answer, we start from down to the top. So invariably 35 base 10 will now be 100011 base 2, and that's what we are going to have. So this particular question now is a question. This particular question is a question in the objective question number 4 in the year 2012. So if you are given any question in base 10, you can be asked to convert it to base. In this case now it's base 2. You can be asked to convert it to base 3, base 5, base 7, irrespective of the base that you are asked to convert it to. Just use that particular base to divide what you are given. Then once you finish with the division, you now start rewriting from the bottom to the top. So 35 base 10 is same thing. If you convert it to binary, same thing as 100111 base 2. And of course, we can also convert from binary to dinary, that is from base 2 to base 10. We can also do that. But in this case now, I decided to pick this particular example. But let's say you are given 35 base 10, you are asked to convert that number in base 5. What are you expected to do? Just use 5 to divide 35. Then you write your result from down to top. So that's what you are going to get. So that is how to do the conversion of base 10 to any other base. So that's how to do conversion of base 10 to any other base. And not only that, I want us to consider this example. This question is objective question 7, 2022, where we have if M5 base 10 is equal to 10010112 base 2. Find the value of M. Find the value of M. Now, so now let's look at this now. In this case now, what do we do? In this case, what do we do? This question now, this particular question is 2002, objective question 7. So in this case now, what do? We want to find M. M signifies a particular digit, but we don't know M. But if I'm able to convert this base 2 back to base 10, then I'll be able to find the value of M. So what do we do here? I'm going to write this as 10011011. In this case, it's base 2. Now let's use this opportunity to, if you want to convert any other base to base 10, we put 0 here. The second one will be 1. This third one will be 2, 3, 4, 5, and 6. In order not to waste time when we are dealing with this type of problem, wherever we have this 0, you don't need to waste your time because it's going to cancel out. 0 multiplied by anything will cancel out. So the implication now is that we are going to have 1 multiplied by, this is the base, 2 raised to the power 6. Everything that we have here represents the power of each of these digits. Then plus, normally we also have is 0 multiplied by 2 raised to the power 5, plus is 0 multiplied by 2 raised to the power 4, then plus 1 multiplied by 2 raised to the power 3, plus is 0 multiplied by 2 raised to the power 2, plus 1 multiplied by 2 raised to the power 1, then plus 1 multiplied by 2 raised to the power 0. That is what we are going to have. So please, I want us to note something. If you are converting from any other base to base 10, this is what we are going to do. If you are converting from base 10 to any other base, you use the long division method. If you are converting from any other base to base 10, then you multiply it, you are going to use this power. So in this case now, 2 raised to power 6, that is 2 in 6 places, that will be 2 times 2 times 2, that will be 64. 1 times 64 is 64. Plus, normally, if you don't want to waste your time, this one will vanish, it will be 0. Because 0 multiplied by anything is 0. Plus, this one will also vanish, it will be 0. Plus, in this case now, 2 in 3 places is 8. Plus, this next one will be 0, plus 2, then plus 1. 2 raised to power 0 is 1. That is law of indices. 2 raised to power 0 is 1. Okay? So from here now, this is 64. 64 plus 8, that's 72. Plus 2, 74. Plus 1, 75. So we are going to have 75 base 10. Look at what we are given. Is it not M5 base 10? So what is the value of M here? The value of M will be 7. And that is what we are asked to find. So the value of M is 7. So let's note that if we want to convert from base 10, from any other base to base 10, we are going to use this multiplication. We multiply it in this sense. But if you are converting from base 10 to any other base, you divide, like the first example that we consider. Then let me just take the last example under this number base before we move to another one. So let me take the last example under this. That is where that is what is called bisemal. Bisemal in the sense that if we have something of this nature, we say convert when we have some decimal, something of this nature, 0 base 2 to another, to a number, or we say another, or a number in base 10. Base 10. In this case now, we should know what to do. Look at this one, is called bisemal. That is the subtopic. That's what we call this. It's called bisemal. So why is it called bisemal? Now let's look at this. In this case now, we have 11.11.011 base 2. It involves decimal. So once number in base involves decimal, then it is called bisemal. So it is called bisemal. So what do we do here? It's still the same thing, just as if we are converting number from base 2 or from any other base to base 10. So we are going to start from, this is decimal. Any value after decimal is fractional. So this first one will be 0, here will be 1. Okay, this first one will be 0, here will be 1. But the first digit immediately after that decimal will be -1. Just like when we have number line. On a number line, 0 is the center. Here is 1, 2. No, here is -1, -2. Here will be 1, 2. So in this case now, any digit that you have after decimal is fractional. It can never be a whole number. So please, let's know that. So when we have this type of question, for instance, we have to convert this to a number in base 10. Then this will, the first one will be -1, the second will be -2, while the last one will be -3. Okay, that's what we are going to get. So here I'm going to have 1 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. Now plus this first one is 0. I'll say is 0 multiplied by 2 raised to power -1. That is the implication. So when you have a number, the first digit after decimal is -1. The second one will be raised to power -2. The third one will be raised. So this next one will be plus 1 multiplied by 2 raised to power -2 plus 1 multiplied by 2 raised to power -3. So this type of question, the general topic is called bisemal. Okay, bisemal. So here we are going to have 1 times 2, that is 2, plus any 2 raised to power 0 is 1. So 1 times 2, 1 times 1 is 1, 1, plus this will be 0, because 0 will cancel out. Then here, I'm going to have, 1, of course, 1 is identity, doesn't have anything. 2 raised to power -2 will be plus 1 all over 2 raised to power 2, then plus 1 all over 2 raised to power 3. Of course, this is law of indices. This is the negative form. If you want to change it to the positive form, it will be in form of reciprocal. That's 1 all over. For me to remove this minus, I'll write it in the form of reciprocal. That will be 1 all over. And that is what we are supposed to do. That's what we are supposed to do. So in this case now, we are going to have 2 plus 1 plus, this is 0. Then this 1 all over 2. 2 squared is 4. So that will be 1 all over 4 plus 1 all over 8. Then of course, this same thing as 2 plus 1 is 3. And we have 3 plus 1 divided by 4. That will be 0.25. Of course, they allow you to use calculator this time around. Then here, 1 divided by 8. 1 divided by 8 will be 0.125. So if you add everything together, you're going to have 3 points. If you add everything together, you're going to have 3.375. And that will be the value. So this will be the value in base 10. Okay, that will be the value in base 10. So this is what we are asked to find. So under the first topic that we consider today, which is number base system, I want to do the recap. We have this what we have been able to establish that if you are converting any number if you are converting any number to base, if you are converting any number from base 10 to any other base, we said that we are going to use the long division. For instance, if you are given 40 base 10, if you are asked to convert this to base 8, just write 40, then divide it by 8. That's what you are going to do. So 8 here is 5, remainder 0. 8, can they divide this? No. Then the remainder will be 5. So 40 base 10 is same thing as, just like you write your answer in this form. That will be 50 base 8. 40 base 10 is same thing as 50 base 8. Okay. So if you are given any number in base 10 and you are asked to convert it to any base, you use long division. But if you are given any number in whatever base and you are asked to convert it to base 10, you are going to multiply it through. Like with the example that we gave, if you have something like 25 to 25 base 4, if you have to convert this to base 10, if you have to convert this to base 10, this will be 0, 1. So this will just be 2 times 4 raised power 1 plus 5 times 4 raised power 0. So in this case, we have 4 raised power 1 is 4, 2 times 4, that is 8, plus this is 1, that will be 5. So that will be 13. So 25 base 4 is same thing as 13 base 10. So if you are converting from any base to base 10, you use the multiplication method. Then if you have number in base 2 that involves decimal, it is called bicimal. Like the example that I gave, that particular example is 1997 theory question, 1997 question 1. The particular example that I gave, the third example. So it is possible to have something of this nature, 10001.111 base 2. You can be asked to convert this to base 10. So what do? Just 0, 1, 2, 3, 4. All this represents the power. Then here, immediate after decimal will be minus 1, minus 2, minus 3. So this is how to convert bicimal to decimal. So that is that about number base. So we have so many questions in the past question. But once you understand the principle, there will not be any problem. And that is what we are trying to establish. That's what we are trying to establish. Then you can also have questions when we have indices. When we have indices and standard form. Standard form. I just want to combine the two topics so that we are not going to standard form. We are not going to waste time. So under this, what do we do when we have indices and standard form? So what do we do? Of course, let me just do a recap for the law of indices. You know, when we have something of this nature, a raised power s. This a is called base. Why this s is called the power? Is that you call it power, or you call it exponents? You can call it exponents, or you call it power exponents, or index. You can call it index. Okay. So if you have something of this nature, if you want to reduce in algebra, if you want to reduce the normal form of writing something or in form of multiplication, we use this form. For instance, if I have 10 multiplied by 10, multiplied by 10, multiplied by 10, if I don't want to stress myself, this is 10 in 4 places. I'll just say 10 raised to the power 4. The implication is that once I have this, I know that I have 10 in 4 places. So that's how to just in the knowledge of indices help us to reduce whatever we are dealing with. So under indices, we have laws that actually guide indices, and those laws we are expected to recall it offhand. The first law says that if you have a raised power x, where a is the base, x is index, multiplied by a raised power y under indices, provided that the base are equal. The base must be equal before you talk about indices. So this base must be equal. The law says that this will be a raised power x plus y. That is, the base must be equal. If the operating sign is multiplication, go ahead and add the power. That's what the law says. The second law says that if you have a raised power x divided by a raised power y, the law says that it will be a raised power x minus y. Look at, the only difference there is that the operating sign in the first law is multiplication. Once the operating sign is multiplication, you add the power together. The index, you add this together. Then the second law, when the operating sign is division, you are going to subtract the power. Okay, that's the second law. Then the third law says that if you have a raised power 0, that is anything raised to power 0, it's going to give us 1. Then there's another law that says that if you have a raised power minus x, that is, if the power attracts a negative sign, and you want to write it in the positive form, we are going to write it as a reciprocal. That is, you have something like 1 over a raised power x. Okay, basically, these are the 4 laws of indices. Every other ones that we call laws is something we can actually generate. As by the time I give example, you are going to see it. So you should be able to recall all these laws often. You don't need to cram anything. You don't need to cram anything. These laws will come out naturally. The base, provided that the base are equal. If the operating sign is multiplication, you add the power. If the operating sign is division, you subtract. Anything raised by 0 is 1. Of course, we saw the application of this under number-based system. So anything raised by 0 is 1. Then if the power attracts a negative sign, if you want to write it in positive form, it will be in form of reciprocal. That's what we are going to get. So let's take about 2 or 3 examples under indices before we go to standard form. Before I go to standard form, we have a lot of topics to cover today. So before I go to standard form, for instance, let's take this example. In this example, we have to simplify. Simplify. After this, I'll tell you the difference between simplification and when you are asked to solve. You can only solve an equation. Before we talk about solve, if the question says solve, there must be presence of equality sign before you can talk about solve. Because if the question says solve, that simply means that you are required to find a particular unknown. But if you have to simplify, just reduce to the barest minimum. That's just the beginning of this. Multiply by 27 raised by n plus 1. So this question is just the theory question, 2001 theory question, question 2. This particular question is 2001 y question 2. This is a theory question. So, but we do have question under this type of question in the multiple choice question, objective question. So it's very simple. What do we do here? You see, when you are given this type of question, the first thing that will come to your mind is that 3, 9, 27, they have something in common. They have something in common. So since you have 9, since you are sure that everything has got something in common, then try and write everything as an index of 3. This is what I'm trying to say. Here we have 1 over 3 raised by 5 raised by n. Multiply by. Can I write 9 as index of 3? Yes. 3 times 3 is 9. So I know that 3 raised by 2 is equal to 9, right? So instead of 9 now, I'll change it to 3 raised by 2. Then, of course, this is n minus 1. That will still be there. Okay? Then multiply by 27. 3 in 3 places. 3 times 3 times 3 is 27. So instead of writing 27, I'll change this to 3 raised by 3. That's what I'm going to do. Then, of course, there is this power there before. N plus 1. Just put it there. Okay? Then from the third law of indices, I can write everything on a straight line. Law that says a raised by minus x is as 1 over a raised by s. So if I have a raised by s, I should be able to rewrite it in this form. What I'm trying to say in essence is that instead of writing this form reciprocal, I can say this empty as 3 raised by minus 5n. That's what I'm trying to say. That is, just bring under indices, just record the loss and apply it. Automatically, the solution will come out naturally. Then you have 3 raised by. Let's open up what we have in this bracket. 2 times n. This will be 2n minus 2. Then multiply by 3. Let's open up 3n plus 3. So we have everything now. You realize that the base are equal 3, 3, 3. And the operating sign is multiplication. What do we do to the power? We just add all the power together. Then we get our final answer. Okay? Just since we have been able to rewrite everything, the base in the same form, we have been able to rewrite the base in the same form. Then the operating sign is division. Okay? This is division. It's multiplication. So the law says that we should add everything together. I will only pick one now. Then I will add all this power together. Then I'm going to have minus 5n plus 2n minus 2 plus 3n plus 3. And of course, something can cancel out. I will have 3 raised power n plus 3n is 5n. 5n minus 5n. So this will cancel out. 2n plus 3n is 5n. 5n minus 5n is 0. Then at the end of the day, I have 3 minus 2. Then at the end of the day, I have 3 whole number. 3 minus 2 is 1. So 3 raised by 1 is 3. So it's as simple as that. So in this case now, we are able to recall about 2 or 3 laws of indices. So we realize that we are able to get the answer. The answer comes out naturally. So just apply the laws. Now you are given a question under indices. So just apply the law, then you realize that we are not going to have any problem. Okay? Let's take one more. Okay, in this case now, the question says if 9 raised power 2x minus 1 is equal to 81 raised power x minus 2 all over 3 raised power x. So the question now says that we should find x. So this question is why question 1992 question 1 is also a theory question. Of course, we also have question indices question under objective. Simple question. The first example that I gave under indices and this, the only difference is that first one, we are just to simplify. We are going to get a particular value, which is a constant. But in this case now, this is an equation because of the presence of equality. So in this case now, we are going to get the value of x to be something. So when you are asked to solve a particular problem, it simply means that we are going to have a variable. We are going to get the value for a particular variable. In this case now, the variable is x. So we are going to get the value. The answer that we are going to get here will be x is equal to something. But if you have to simplify, just reduce it to the barest minimum, then write out your answer. Do some cancellation and write out your answer. So this second question now is an equation we are asked to solve, but we follow the same principle. This is the base here is 3, here is 81, here is 9. So they have something in common. I can write 9 as index of 3. I can write 81 as index of 3. So that the first step is that I'm going to change this 9 to 3 raised power 2. That is, I'm going to have 3 raised power 2 into bracket. I will write the power 2x minus 1, which is equal to. Then what am I going to do here? I also already write 81 as index of 3. 3 in 4 places is 81 because 9 times 9 is 81. Then 3 times 3 is 9. So 3 raised power 4 is going to give me 81. So I'll change this to 3 raised power 4. 3 raised power 4. Then I'll just write the power all over 3 raised power x. Now look at, I'll open up here. I'm going to have 3 raised power 2 times 2. That's 4x minus 2. That is the left hand side. I've been able to show what I have at the left hand side. Now let's go to the right hand side. Here now, at the numerator I have 3. 4 times x, that will 3 raised power 4x minus 4 times 2, that is 8. Then all over 3 raised power x. Of course, this is division. This line is division line. So I'm going to apply law of indices to the left hand side, right hand side now, and combine everything together. So I'm going to have 3 raised power 4x minus 2 to be equal to 3 raised power 4x minus 8, then minus x. What do I do there? This simply means 3 raised power 4x minus 8 divided by 3 raised power x. The base are equal. The operating sign is division. I will subtract the power, and that's what I've done here. Okay? That's what I've done here. Then here I'm going to have 3 raised power 4x minus x is 3x minus 8. Then this is 3 raised power 4x minus 2. So at this point now, there's this assertion that we normally do in mathematics. If the base are equal, we equate the power. Okay? And it's vice versa. If the power are equal, we equate the base. So that assertion is allowed in mathematics. If the base are equal, we equate the power. If the power are equal, we equate the base. So in this case now, since the base are equal, I'm going to go ahead and equate the power. I'm going to have 4x minus 2 to be equal to 3x minus 8. Then I can bring 3x here. I'm going to have 4x minus 3x to be equal to minus 8 plus 2. Okay? That's what I'm going to get. So from there now, from there, I'm going to have 4x minus 3x is x. It will be equal to minus 8 plus 2. That will be minus 6. So the value of x is minus 6. So in this case now, we are able to get a particular value for the value of x, and that's what makes it as this one as an equation. Okay, we have to solve for x, and that's what we have been able to do. So you can just go through the past question. We're going to see a lot of examples in the past question under indices and logarithm. So now let's go to standard form. The students actually have problem when it comes to standard form. If you want to write any number in standard form, either positive or negative, the general form of standard form, I'm going to write it now. You should understand the general form. Once you don't know the general form, then when it comes to multiple choice question, objective question, there will be a lot of problems. You only gamble and get 0. The general form of standard form is this form: a times 10 raised to power n, where this a must be between 1 and 9. This a must be between 1 and 9. Then this n can be either positive or negative. It's an integer or negative. Okay, so if you ask to rewrite any number in standard form, this is the general form. You are going to get a times 10 raised power n. A must be between 1 and 9. A cannot be 2 digits. It's not possible. You can't get, if you have to write question in standard form, you cannot get something like 21.4 times 10 raised power minus 8. No, this is not standard form. This is nonsense. If you have to write any number, if you have to write in standard form, or you have to write a particular question, and you have to write your answer in standard form, the first this value here, which represents this A, must be between 1 and 9. You cannot have 2 digits or 3 digits. It's not possible. It must be 1 digit. Okay, that's how to write question in standard form. So when it comes to multiple choice question, there's this problem that they normally created for students, because this can be one of the options. Once you pick something like this, it shows that you don't know what you are doing. So the answer, the value of A, this value here, must be strictly between 1 and 9. Then this n here, which is the power, can be positive or negative. It can even be fractional at the advanced stage, but at the SSC, you cannot have fractional. You understand? So it can only be positive or negative whole number. So let's take one example, but at least I've been able to generalize now that if you have to convert any number in standard form, that is what is required. That is what we are asked to do. Now look at this question where we ask to multiply 3.4 times 10 raised to power minus 5 by 7.1 times 10 raised to power 8, and leave the answer and leave this answer in standard form. So this is objective question 1 2024. So this is objective question 1 2024. So how do we do, what do we do here? You know, there are two things involved here. You first do the multiplication, then you now leave your answer in standard form. So even if you do the multiplication correctly and you don't know how to rewrite the answer in standard form, you are still going to get 0. So what do? 3.4 times 10 raised power minus 5 multiplied by 7.1 times 10 raised power 8. So now see what we're going to do. I'm going to use this to multiply this. Then I'll use this to multiply this. That is, I'm going to get 3.4 times 7.1. Then multiply by 10 raised power minus 5 times 10 raised power 8. These are raised power. So you know what to do here. So if I use 3.4 to multiply 7.1, if I use this to multiply this, I'm going to get 24.14. Okay, that's what I'm going to get. If I use this to multiply this, thank God, the use of calculator is allowed now. You can quickly do that. Then multiply by, here, I don't need to stress myself. It's indices. This will just be 10 raised power, the base are equal. The operator sign is multiplication, just add. 8 minus 5 is 3, it's base power 3. You know, in part of the option that we have in that year is this option. So if you stop at this point and decide to pick the option, maybe A as this is 0, you are going to get 0. Because you have to rewrite this in standard form. Then how do you rewrite this in standard form? You have to shift this decimal points forward here. That is, we are going to have 2.414 times, and once you shift, whenever you shift towards the left in standard form, it's positive. You add to the power. When you shift towards the right is negative. This is 3, raised power 3 initially. If I move this decimal back to the, if I move it backward, this will change to 10 raised power 4. So this is the correct answer in standard form. So please note, when it comes to standard form, this first value must be between 1 and 9. This first value must be between 1 and 9. Then this power here can be negative or positive whole number. At your level, it can only be positive or negative whole numbers. It's possible to be fractional, but that is not meant for your level. So please let's note how to rewrite a particular result in standard form. Okay, so this is what we're going to write. This is what we're going to get. Of course, this first one, as I said earlier on, is part of the option. This is question 2024, question 1, objective question. Why? So this is part of the option. Maybe A, they give this. B, this is the answer. If you decide to pick this, of course, you have been able to multiply, but you have only done one part of the question. You didn't do the second part. The first part says multiply. That's what you have done here. You have fulfilled half of the requirements. And that's another requirement. Leave your answer in standard form. If you decide to pick this option, it's 0. You're not going to get it because it's multiple choice question. Once you don't get it, you don't get it. So to write in standard form, let's note the first digit here, what we have here must be between 1 and 9. Then this power can be negative or positive. Okay, so that is that about standard form. Of course, we have a lot of questions. So I'll just want to go to logarithm because of our time. Let me go to logarithm. We have so many questions, more than 70 questions. If you check from 1988 to 2004, we are going to get more than 70 questions when it comes to indices. Even standard form, you can get up to 40 or 50. You understand? But we can't, because of time factor. I want to establish the fact. Let's know the basic requirements, rules on what to do. That's what I'm trying to do. That's what I'm trying to do. Okay? So logarithm. We are going to look at the two approaches when it comes to this logarithm. Logarithm to base 10. Then logarithm when we have less than 1 or 1. The one that we are going to that will be required to use table. Okay? But I will try and do justice to this. So when we have logarithm to base 10, for instance, when we have log P, say A, plus log Q, A. Okay? This same thing as when it is addition. The law says that it will be log P multiplied by Q, A. Okay? That's the first one. Then if you have it together like this, it can be splitted. It's vice versa. Once you have equality sign, it shows that it can either move from left to right, or if you have the question in the form of right, you can split it as what you have at the left hand side. You understand? So this is the first one. The second one is that when we have log, say P, A, minus log Q, say A, is same thing as log P divided by Q. Okay? So that one is also vice versa. The third law says that if you have log P, A, say raised to power S, this log P now has a power. The law says that this power can come down to have X log P, then A. Okay? That's another law. Then what I want you to note here is that if you are given the log without base, for instance, if you are given log without base, say log, if you are given log 3, no base. If you are given log 2 without base, you assume the base to be 10. That's standard in mathematics. If you are given any log without base, assume that base to be 10. For instance, no, this is base A. So if you don't do any base, let's say we are not given any base here. We are not given any base here. So the standard in mathematics is that you assume this base to be 10 if you are solving any problem. If you are given a logarithm without base, assume the base to be 10. That's the assumption. Then these are normal logarithm. Okay, we can have natural logarithm when we talk about in x, log x, but that will actually help those in further mathematics. We don't really need that. I don't think we don't have that is not part of the scope. So this law says that the power can come down, and if you have the power like this, something of this nature, if you have a question in this form, you can take this now back to this place. It's vice versa because of this presence of equality. So if you have log with the same base, log A, base A, it is 1. So if the log and the base is the same, it's going to give us 1. Okay? That will give us 1. Then if you have log 1, let's say you are given log 1, irrespective of the base, say base 10 or base 8 is 0. Okay, that's the fifth one. So if you have log and the base will be the same, it is 1. If you have log 1, irrespective of the base, is 0. So these are the 5 required laws that we use when we have log to base 10. Okay, the one I'm talking about the other time is when you have log x, this type of log. Okay, these are called natural. This is called natural logarithm. So this same thing as in x. Okay, but the knowledge is not. You don't really need the knowledge in mathematics. It's only for mathematics students do. Okay, so you don't need knowledge. 5 rules or laws that you are expected to know when it comes to logarithm. Okay, so let's take one example. Let's take example on logarithm. Here, if y minus 1 log 4 is 10 is equal to y log 16 base 10 without using mathematical table or calculator, find the value of y. Look at this type of question. So this question is 2017, question number 1, theory part. This particular question on the board is 2017, question 1. So this is a theory question, 2017, question 1. So what do we do here? What do we do here? So I'm sorry, before I solve this, there's what we call change of base. There's something what we call change of base. That is, if you have log A base B, we can split this as log A divided by log B. So once we split it, the base will change. So please let's note this part of it, change of base. It's called change of base because the knowledge will be required here. It's called change of base. If you have log A, B, so we can split it to be log A, then log B. Just that they have different base, the base will change. That's just the implication. Okay. So now let's go to the question where we have y minus 1 log 4 10 is equal to y log 16 10. So what do we do here? What do we do here? You know, the third law of logarithm says that if you have this here, it can come to this as the power of this 4. That is, I can write this as log 4 raised to power y minus 1 base 10 to be equal to log 16 raised to power y base 10. I can rewrite it like that. Of course, this is 4, this is 16. There's something that is common. I can write 16 as index of 4. That is, I will say 4 times 4 is 16. So instead of 16, I can change 16 to 4 raised to power 2y. That is, 16 is 4 times 4. So I can write something like this. So okay, that is another step. I decided to jump a particular step there. Look at it very well. I decided to jump a particular step there. Okay? Or if I don't want to follow that approach, in order not to create problem, I can. If I don't want to follow that approach, in order not to create problem, because some people might not understand what I'm about to do now, I can just do this. I'll say y minus 1. I'll use the knowledge of change of base here. Instead of log 4 10, I'll change this to log 4 divided by log 10. Okay, is allowed. It's called change of base. Then is equal to, I'll say y log 16 10. Okay, log 16. Then I can change 16 as what? 4 raised to power 2. If I do that, 16 as 4 raised to power 2, these two can come down. So that at the end of the day, I'm going to have y minus 1 log 4 base 10 and a bit log 10. If you go to these two can come down to be 2y log 4 log 10. That's what we are going to get. So from here, I can start to multiply through by log 10 base 10. Log 10 divided, I will multiply through by the reciprocal. I can start to multiply through by the reciprocal. That is, I will say y minus 1 log 4 base log 10 multiplied by log 4 log 10 multiplied by log 4. Whatever you do to the left, you do to the right is allowed. This will be 2y log 4 log 10 multiplied by log 10 log 4. So that this will cancel this, this will cancel this, this will cancel this. At the end of the day, I'm going to have y minus 1 is equal to 2y. I start to follow this long approach because of some people. So at the end of the day, I can bring in this, I will have y, or I will say minus 1 is equal to 2y minus y, irrespective of how you want to approach it. So that minus 1 is equal to y. So y is equal to minus 1. That will be the value of y. Okay? That will be the value of y. So that will be the value of y. So please let's take note. So if you have any problem, if you have any question, under log to base 10, this is how to approach it. Okay? This is what we do. You can be, at times, you'll be given something like this, either in objective or theory. They'll say, if log 2 is equal to 0.3010, say log 3 is equal to 0.4771. These are the values. I know that now. Either you have log 10 there, log 2 base 10, or if either this base is there or not. I've said it earlier on that you assume the base. If you are given log without base, you assume the base to be base 10. So we have established that fact. Okay? If you have something like this, the question can say, find log 6, then B. You can also be asked to find log 27. You can get something, you can have question in this form. If you check past question, there are questions in this form. So in this case now, you can also have under log to base 10, you can have this first one will now be log 6. What is log 6? I can split 6 as 2 times 3. This will be log 2 times 3. Then in this case, when I apply, if it is multiplication, I can split it as addition. If it is division, I can split it as subtraction. So I can write this as log 2 plus log 3. Okay? So what is value of log 2? Just put it there. 0.3010 plus what's value of log 3? 0.4771. Then just go ahead and add the two together. And if you do the addition correctly, you have 0.7781. That will be the answer. So there are questions of this nature. There are questions of this. Somebody said you have question. Okay, you mean what I did the other time under change of base is allowed? I don't. You can type your question. Just type your question. Please type your question there. I will address it. Type your question. Type your question. Okay, like this first one, A is going to give us what we have on the board. When it comes to 27, you can just say you can write 27 as index of 3, so that you are going to have log 3 raised per 3, because 3 times 3 times 3 is 27. Then the third law says that this 3 can come down, so you can have something like 3 log 3. Okay, you can have something like 3 log 3. You can have something like 3 log 3. So what is 3 log 3? I'm trying to. You can have 3 into bracket log 3. 0.4771. That's what you're going to get. When you multiply this, you are going to have 3 times 7, 21, 3 times 7, 23, 3 times 7, 14. That will be 4.0. No, that will be 1. So that's what you're going to get as a solution to the second one. Okay? That is what you're going to get as a solution to the second one. So you can also have question in this one, even in mathematics. So you can have question in this one, even in mathematics. So this is when we have log to base 10, that we apply the laws of logarithm. So don't just be flexible. Look at the question. You see, you can approach any problem, provided you comport yourself and you have this assumption that you can do anything. So just look at the question and think about the topic. Okay, what will be required here? Go ahead and apply it, and then you are going to get your answer. Okay, you can have this one. All right. So then there's this other one where we use mathematical table. When we have logarithm of number less than 1 and greater than 1. Less than 1 and greater than 1. Okay, somebody said it's confused. Okay, I'm sorry. Somebody's asked a question on change of base. I said it's allowed. Yes, there's what we call change of base. There's what we call change of base. If you have log A base B, it's the same thing as log A all over log B. So both of them will not be log, but this is log here, log A base B here. So they are going to have same base here. It's called change of base. We can split it. Okay, we can split it. It's allowed. We can do that. We can do this type of problem. It's possible. Okay, we can do that. We can split it so that we have different logarithm, but they're going to have the same base. It's allowed. You can please check your textbook. Check textbook. It's called change of base. It's allowed. It's allowed. You can do something like that. It's allowed. Okay. Please check your textbook. Check textbook. Check your textbook. That new general, the project, whatever textbook you are using. So we also have reading. And many students have problem. Please, I want us to listen on this. When we have logarithm less than 1, greater than 1, or less than 1, now we talk about the characteristics. Okay. So if you have logarithm greater than 1, the question will be in this form, maybe 280. All the questions that you are going to get will be more than 1. But if you have question under logarithm less than 1, you can have something like 0.0004. Okay. I'm going to use just one example to explain this concept, either less than or greater than. For instance, you can have something like this. The question says, evaluate. We have something like this. The question has said, use log table. Use logarithm table. We have to use logarithm table. Use logarithm table to evaluate time 1.874. Something like this. We have to use logarithm table to evaluate this. So, okay, standard form. Okay, I'm going to do recap. But please, let's be mindful. After this, after explanation on this, I will do recap on standard form. But please, let's be mindful of time. Unless you want us to do this till tomorrow morning. Okay? So we can go and come back. We can come back. I can organize another class at night. It's fine. So what I'm trying to say now is that when you have problem like this, the question says use logarithm table. What do we do? When you know this, all these questions now, they are number greater than 1. So this is logarithm of number greater than 1. This is 23.45 is greater than 1. 300 greater than 1. 1.87 is greater than 1. So if you want to evaluate this, what we normally do is that we say number, then we say log. That's what we normally do. Okay? But because we have division, I try to partition into 3. So you write the first number, 23.45. The operating sign is multiplication. The second one is 300. Then that is the numerator. We are going to look for the value of the numerator. So look at, if you know, look at, there are two values here. And if this decimal point here is here immediately after the first digit, what you first write here will be 0. It will be 0. But because it's after the second digit, we are going to write 1 here. Point. This one, there are 3 digits, 1, 2, 3. The decimal point will be at the back of this one. Write 2 here. Point. Please look at it very well. If you have any question, ask so that I will go over it again. When you have logarithm of number greater than 1, that's what I'm trying to address here. If the decimal point is immediately after the first digit, it is 0 that we write here. So you put point. You now go to your log table. Use of first table is allowed. You go and check 23. You go and check 23 under 4, difference 5. When you check the back of your log table, you see where we have logarithm of number. We also have anti-log of numbers. We have anti-log of numbers. So you have anti-log of number. So yes, I'm going to teach circle theorem. I will teach circle theorem. So we also do that. I'm going to teach circle theorem. It's important. I'll talk about. I'll also teach bearing and distance. And if time permits, we are going to talk about latitude and longitude. So I'm not only that, we talk about graph because every year you must get graph. Every year there must be graph, either quadratic, trigonometric graph, or GIF, frequency cumulative frequency curve, or inequality graphs. We are going to talk about graph. Yes, we'll talk about graph. I'm going to teach circle theorem because circle theorem will usually come out either in objective or theory. Even objective, you have about 4 or 5. So don't worry about that. We are going to teach circle theorem. Please let's just concentrate. Let's concentrate, please. Even if you don't need this, some people does not know this. So look at when we have logarithm of number greater than 1. If the digits, the decimal point is immediately after the first digit, what we are going to write here is 0. Point. You now go to your log table. You are going to check log 23 under 4, difference 5. If log 23 is not, this is not an assumption. If you check your log table, log 23 under 4 is now 2451. You now go and check the difference. If the difference is 6, you put 6 here. You now add everything together. So you are going to have 2457. So we are going to put 2457 here. That's what you do. Okay. In this case now, we are going to check log 30 under 0 because it's just 300. Check log 30 under 0. Okay. So you go to your first table under the logarithm of number. Check log 30. Trace it under 0. Write down the 4 digits here. Then, because the operators are, let's say this is 1247. It's not an assumption, but the example I'm about to give now, you are going to see the written there. So, because this what you have here is multiplication, we are going to add these two together. You do the addition. So this will be 4, here will be 0, here will be 7, here will be 3, here will be 3.3. But because we have denominator, we have value at the denominator, that's why I decided to partition this into 3. So I can write this here so that the work will be neater. 3704. Okay, that is, I put numerator here. In some questions, it's possible to also have something like times something at the denominator that you'll be required to solve. Then you write out the answer there. Before you know, we do the normal subtraction. So what do I have here? 1.874. Of course, the decimal point here is immediately after the first digit. I'm going to write 0 here. 0 points. I will now go to the first table to check 18 under 7 difference 4. That's what I'm going to do. I'll check 18 under 7 difference 4. I don't know 18 under 7 difference 4 because I didn't check first table. Let's assume that is 4850. It's not an assumption, but the question I'm about to give, the right question I'm about to give now, we are going to check it out. I'm just trying to explain on that when we have logarithm of number greater than 1. So I will put this one here, 0.4850. This is division sign. So the implication of that division sign is that I will subtract this from this. So if I do the subtraction, here will be 4, here will be 5, 1, 6, here will be 8. I'll bring 1 from here, 12, 8.2. Once I'm able to get this value here, then the implication is that these two, I will not touch these two. I will just pretend as if this two is not there. But we are going to see the implication. I will not go to the anti-log table. I will go and check 0.88 under 5 difference 4. I will go and check 0.88 under 5 difference 4 on the anti-log table. So that's what I will check. Let's say it is 3048. So what is the implication of these two? Because it has implication. If what I have here is 0, the decimal point will be here. If what I have here is 1, the decimal point will be after the second digit. But if what I have here is 2, then I will have 304, which will be the final answer. So if you have to find the logarithm of number, if you have to find the logarithm of number, the first clue for the logarithm, once you finalize everything, you go to the anti-log table to check the anti-log of that value and write it in this form. So now let's pick a particular example from past question now. We pick a particular example for past question. That question I'm about to write now involves both less than, logarithm of number less than 1 and greater than 1. Okay? So let's see. Let's see that particular example. The question says, use log table to evaluate. This question is 1997, question 6, theory. So you can check your past question. It's 1996, question 6, 1997, question 6, the theory part. Now look at the question very well. So check that denominator. You know that denominator is written in form of standard form. So I can write it as normal form if I don't want to waste my time. Check that denominator. It's written as standard form. So if I don't want to waste my time, I will decide to write it as normal form. Now look at the implication. This one is logarithm of number greater than 1, 15 point something, 0.05. This one also is 695. If I decide to write it as own number, as normal number, I don't want to write it as standard form. At normal form, it will be 695. Because times, if I use this, I'm going to get 695. But look at this one. It's 0.006. So this one is logarithm of number less than 1. We are going to see the implication. That's where we are going to be talking about bar 1, bar 2, bar whatever. So it simply means negative. So what do we do here? Now let's look at it. Let's solve this together. I'm going to have number, then log. But because there is division, something at the denominator, I will create 3 columns down. The first one is 15.05. So this 15.05, we are going to use the actual value now. No more assumption. So in this case now, 15 here, 15.05. Because the decimal point is at the back of the second digit, I'm going to put 1 here. Point. I will now go to the log table to check 15 under 0 difference 5. So if you check 15 under 0 difference 5, you can check it. You are going to get 1775. That's what you are going to get. Okay? Then this one is multiplied by, this one has square roots. At times, if this one, they may decide to write this in this form because some people will just be, they make this, when you have 0.00695 raised to power half. If this same thing as this one. Square root simply means raised to power half. So what if the question is written in this form? Hope we are not going to complain that this one is difficult. It's not difficult, it's still the same thing. They might decide to write the question like this. Say 15.05 times 0.0065 raised to power half all over 695. It's still the same question. Okay? It is still the same question. So please, let's note. This is greater than 1. This is less than 1. Let's see the implication now. Please, because of our time, I want to be a bit fast. But at the same time, people must understand what we are doing. So please, because of time factor, so this first one is clear. Look at that second one. We cannot do this one directly. What is required is that I'll first write what I have inside, which is 0.00695. Okay. Now let's see the implication. I said if the decimal point is immediately after the first digit, I'm going to put 0 here. If it's after the second digit, is 1. What if it's immediately before the first digit? Immediately before the first digit is going to be -1. Okay. If it's immediately before the first digit, it will be -1. Second digit -2. Third digit -3. So instead of saying -3, I'll write bar 3 points. Please look at it very well. Look at it very well. Please look at this very well. This is logarithm of number less than 1 when we want to use log table. If the decimal point is immediately after the first digit, we put 0 here before we go to logarithm table to go and check. Okay, the characteristics 15 under 5 difference 0. If it's like this one, the decimal point is immediately after the second digit, so we put 1 here. Look at this. If you have something like 0.695, if this is what you are given, because this decimal point here is immediately after the first digit, I'm going to have bar 1 here. That's -1. Bar 1, view it as -1. Okay. If it's immediately after this second digit towards the left, it will be bar 2. But look at this one. Here is 0. If here is 0, this place is 0, -1, -2, -3. So this will be bar 3. So this will be bar 3. So if this one is bar 3, then what is the implication? You will now go to your fourth table, you disregard all this one. You go and check 69 under 5. Okay? Just go and check 69 under 5. Just go and check 69 under 5. So if you check 69 under 5 in your fourth table, you are going to get 8420. But that's not what we are given. We are given square root of this. So we now write square root of 0.00695. What is the meaning of that square root? You divide by 2. If this cube root, divide by 3. If this is quart root, divide by 4. That is, I'm going to have bar 3.8420 divided by 2. Why do I divide this by 2? Because this is square root. If this cube root, say cube root of 0.00695, I'm going to divide by 3. Okay? So, okay? If it is quart root, say quart root, something like this, I'll divide by 4. But if the square, let's say it's possible to have something like this also. Please check past question. We can have something like 0.00695 square. So if the square like that, I will multiply by 2. If this cube, I will multiply by 3. If it is quart raised by 4, I will multiply by 4. So let's see the implication. Let's see the implication because we don't really have time. We are writing the exam tomorrow. So I'm just using one particular question to explain every possibilities that we can get. So do we understand? If it is square root, if the square root, you divide by 2. If this cube root, say we have something like cube root here, divide by 3. If this quart root raised by 4, you divide by 4. But what if it is possible also to have something of this type, they put times cube, square, cube, quart. If that's what you have, then you multiply. If this square, multiply by 2. If this cube, multiply by 3. If this quart, multiply by 4. Okay? So I want us to understand. Don't worry, we are going to do restoration of either plane or solid shape. This is a matter of time. Please, let's concentrate on this. After this, I'm going to drop this, go to another topic, okay? So please, just be patient. So look at the implication. Because of this square root now, I divide by 2. Then, can you divide this directly? No. There's this tactics that we normally use. Because 2 cannot divide this without remainder. I'm going to change bar 3 to bar 4. You feel that bar as minus. Okay? So for me to be able to solve that now, this is what I will do. I will not change this now. For me to be able to do this, I'll change this to bar 4 plus 1, 8420. Okay? Divided by 2. I'm trying to explain. What is minus 4 plus 1? It's not 3. It's not minus 3. 2 cannot divide 3. If 2 divide 3, there will be remainder. And if there is remainder, there will be problem. So I would rather rewrite this bar 3 to bar 4 plus 1. So that at the end of the day, I'm going to get something divisible by 2 without remainder. Okay? That's what I'm about to do now. Then if I do that, what will I get here? What will I get if I do that? I'm going to get, this is what I'm going to get. I'm going to get 2 divided by bar 4. That will be bar 2. Okay? Instead of, look up everybody. Instead of bar 3, if 2 divide 3, there will be remainder. And once there is remainder, we're going to have problem. So I'm going to rewrite this bar 3 as bar 4 plus 1. So that 2 divided by bar 4 will be bar 2. Of course, then I will now say 2 divided by 18, the one that I put here, that will be 0.9. 2 divided by 18 will be 9. 2 divided by 4, 2. 2 divided by 2, 1. 2 divided by 0, 0. This is what I'm going to get. Look at it very well. It's somehow trickish, but it's something you can get. Okay? So at the end of the day, the numerator will now be, you know what is the numerator? This multiplied by this. So I can rewrite it outside, then I will add it together. 1.1775, then plus, what do I have here? Bar 2.9210. So the numerator, I call it numerator. The numerator now will now be addition of these two. This multiplied by this. This is this. And this other one, the value here is this. So I will add these two together. That's going to give me the value of the numerator. Okay? That will give me the value of the numerator. This is square root. Okay? So if I add this, I'm going to get 5, 8, 9. This is 0. Then I'm left with 1. 1 plus 1 is 2. In this case now, this will now be 2 minus 2. This will be 0. Okay? So let's look at it very well. This will be 0. Here it's going to be 0. Okay? Look at it very well. This bar 2, view it as minus 2. When I add this plus this, 9 plus 1 is 10, 0, remainder 1. 1 plus 1 is 2. 2 minus 2 is 0. See, this is what I'm going to get as the value of my numerator. That's what I'm going to get as the value of my numerator. We now go to the denominator. As I've said earlier on, this same thing as, no, this 10 is part 2. 1, 2. The same thing as 695. So this same thing as 695 is the same thing as 695. This is very simple. 0, 1, 2. I will have 2 points. I'll go to the log table to check 69 under 5. So if I check 69 under 5 from the log table, I'm going to get 8420. That's what I'm going to get. So here will be 2.8420. Because it's division, because of this division line, I will subtract numerator from denominator. I will subtract, hope you can still see. I will subtract numerator from the denominator. If I do that here, if I subtract, what will I get? This will be 5. Here will be 6. Here will be 5. If I come to this place, I will borrow 1. Once I borrow 1 here, I will be left with minus bar 1 here, minus 1. So on getting to this place, here will be 2 points minus 2. This here will be bar 3. Because initially I have bar 2. No, initially I have 2 here. Okay? Initially I have 2 here. So here will be bar 2. So that's what I'm going to get. So I'm going to get bar 3 here. So please look at it very well. So if there's any question, just write at the comment section. Write at the comment section. I want to just solve this and leave here. So from here now, at this point, I will go ahead and find the anti-log. I will go to the anti-log table. Once I go to the anti-log table, I will check point 25 under 6 difference 5. So if I check point 25 under 6 difference 5, that's what I'm going to do. I will check point 25 under 6 difference 5. If I do that, at the end of the day, I will get 1805. But because I have battery here, the implication of this battery is that I'm going to have 1, 2, 3. That will be 0.00. 1, 2, 3. This is what I'm going to get. Because of this battery, this is what I'm going to get. Then this is approximative. We have to evaluate. We have to evaluate to correct to 3 significant figures. It will be approximately 0.00181. And that's what we are going to get. So question under this is somehow tedious, but it's something we can actually do. So because of our time, I would love to move to set theory. So let me move to set theory now. Set theory. So I'm going to do a general recap on set theory. Then we take 2 or more questions on set. So after set, probably I'll move to quadratic equation. Or people want us to talk about Surds. Okay. After set, maybe I'll go to Surds. I'll go to Surds, or after Surds, then I'll go to circle theorem, circle geometry. Then we can also talk about bearing and distance. Please, let's take it one after the other. Let's take it one after the other. So if you have opportunity, probably for people that write jam next year, we can be having lecture maybe once in a week, so that we take a particular question, a particular topic, we treat it into details, so there won't be any problem. Okay? So there won't be any problem. Sir, are you going to teach us how of logarithm with table? That's what I've just finished. Logarithm with table. That is it. Logarithm with table can either be less than 1 or greater than 1. And that's what that's what I've done. That's what I've done. So please go through what I've done. I can make mistake. I can make mistake. You know, we are not in the normal class. I can make mistakes. So please go through what we are doing. What I'm talking about here. So once there's mistake, you can correct it. Okay? Please go through. Even check the first table very well. What I have here might not be the written. So please, let's check. I will take responsibility for that. Okay? Now let's talk about set theory. What is a set? A set is a collection of well-defined items or objects. The word well-defined must be there. If you talk about sets, the word well-defined is important, because if it is not well-defined, it cannot be set. Okay? For instance, if you have mathematical sets, when you open your mathematical set and check what you have there, when you open your mathematical set and check what you have there, they are the set. We have things that we can use to construct, like 30 by 60 set square, 45 set square, protractor, divider, compass, pencil, eraser. So they are sets. So example of a set is a set of students that we have in secondary school. There are two sets. We have junior class, GSS, and we have SS. Okay? These are sets. So in the GSS, we have subsets. They can be GS1, 2, or 3. These are subsets of this set. SS1, 2, 3. They are subsets of this set. Not only that, even in SS class, some people are in science. Though they are in SS1, no, we can have SS1 science. Some are in humanity. Humanities, maybe arts. Okay? And some are in commercial. Okay? All of them are in SS1, but they are in different categories, different subsets. Okay? But what unifies them is this class, SS1. So if the principal want to see those in SS1, you just say, go and get me the student in SS1. But if the principal want to be specific, you say SS1 science, then arts and commercial or humanities and commercial, they are less concerned. So a set is a collection of well-defined items or objects. And there are some terminologies that we use in sets that we must be familiar with. Without those terminology, there will be problem. Before I give example, I just want to do a recap, so that once I give example, we are through with sets, we go to another topic. The largest set under consideration is called the universal, denoted as this, or in some textbook we have something like this. This is the largest set under consideration. Any set you can think of, for instance, in your school now, the universal in your school is the total number of students in that school, from GSS1 to SS3. Is the largest set, is the universal, and people plus the teachers, principal, administrator, non-teaching staff, they belong to this universal set. But inside this universal set, there could be subsets like GSS1, they are part of this students in your school. GSS2, GSS3, SS1, they are part of this. Okay? The teaching staff, non-teaching staff, the administrative staff, they are part of this set. So the largest set under consideration is universal set. So universal set, okay? That is taken, universal set. For instance, when we say alphabet in English language, you know it's from A, B, up to Z. So that's universal. When we talk about alphabet in English language, then this universal can be broken down to two. We can talk about set of consonants. You know, consonants, we can talk about consonants. So consonants has just 21. Number that we have in the consonants is just 21. That's cardinality. We are still going to talk about that. Then number of elements that we have in the vowels is 5. So when you add the two together, the total element that we have in the set of the alphabet in English language will be 26. So universal is that 26. Consonant is subset, is part of the set in the universal. This other five whereas is also subset. So the largest set under consideration is universal set. Note that. Then there's what we call, we denote sets with capital letters. That is, if I say set A, number of girls in a particular school. So that is set A. We do not set with capital letter, but element of a set with small letter. Okay. If I say set of words in English language, capital letter, what are they? A, E, I, O, U. So we represent elements, members of set with small letter, but that set with capital letter. You must note that. Okay. We just have to note that we represent set with capital letter, but elements or numbers of members are small letter. Then we use curly brackets, not ordinary bracket. If you are talking about set, we use curly brackets. You know, this is not normal bracket. Okay, that's what we use. So then, if you have a set that has no elements, set with no elements is called empty set. Okay, empty set. We are going to see example. We are going to get an empty set. Empty set is given as something like this, empty, or use fine. So if you have this symbol, it's talking about empty set. Okay, set that has no elements are called empty sets. Okay, set without elements are called empty sets. So this is empty set. Then we have signature sets. Signature sets, set with just one element. If a set has just one element, say A, it's called signature set. This and this are not the same. They are not the same. This one no elements. This one has one element. They are not the same. They are not the same. Please let's take note. Okay. Then apart from that, before we take question, I want to establish some. There's what we call subsets. That is like words that we have in English language is a subset of the universal set. When we have all the universal set is all the letters that we have in English language. Subset simply means part of that set. But we can have proper subset if they are the same. If they are the same, you put something like this. That will be proper subset. Okay, that will be proper subset. Okay, that will be proper subset. Then another thing is that if you have two subsets, A and B, let's say you have two sets, A and B, we can talk about the intersection. For instance, okay, let me just use this as an example. This set is 1, 2, 3, dot, 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 10. Look at this simply means we are writing from 1 to 10. Okay, from 1 to 10. This is the universal set, largest set under consideration. If I have another set A that consists of 1, 3, 5, 7, 8. No, this set is subset of this, is inside this one. I can have another set B that's 2, 4, 6, 8. A and B are subset, they are part of the set in the universal. Then I want to establish some concept. If I have A intersection B, this is the notation for intersection. Intersection simply means and. That is, what I'm trying to say is that I want to check out the elements that I have in A and B. Intersection simply means and. If before I pick any element, the element must be in A and must be in B. Okay, let's look at the only element that is common is 8. So in this given example, A intersection B is 8. Intersection simply means and. Then we can also talk about A union B. Union simply means you have that element in A or B or both. Intersection and union or. What is a set? A set is a collection of well-defined items or objects. Is a collection of well-defined items or objects. That is a set. Okay? So when we now talk about union, union simply means you have the element in A or B or both. Even if you have it in both, you pick it once. Let's look at the union. We have one in A. Look at in A, we have one. We don't have one in B. We are going to pick it. Because union simply means you have the element in A or B or both. We have 2 in B, we don't have in A, we are going to pick it under union. We have 3 in A, not in B, we are going to pick it because once the element appears once, you pick it. This is 4, 5, 6, 7. Look at 8. We have 8 in both, so we are still going to pick it. That's the meaning of union. Union of a set. Either you have the element in the first set or second or both. That is union. But when it comes to intersection, it's a must to be in both sets. Okay, so this is intersection, this is union. Then before I want to introduce another thing. It is called the complement of a set. What do you understand by complement of a set? Complement of a set is the element that you have in the universal that are not in that set. I hope you understand intersection now. Intersection, the element must be in both sets. Union, either you have it in the first or second or both. Okay, so I want you to introduce another concept which is called complement of a set. Complement of a set are the elements that you have in the universal that are not in that set. For instance, when we say A complement, just like you say A superscript hyphen, this simply means complement. Or sometimes we say A complement, they just write A then superscript C. Okay, A raised power something like C. Complement of a set. These are elements that you have in the universal that are not in A. That's the meaning of complement of a set. For instance, the elements you have here that are not in A will be 2, 4, 6, 9, 10. So in this case now, in this particular question, A complement will be element in the universal that you don't have in A. That's the meaning of complement of a set. Then B complement will also be the element that you have at the universal that are not in B. That will be 1, 3, 5, 7, 9, 10. Okay? So that is what you are going to get. A complement, B complement. Okay? A complement are the elements you have at the universal that are not in that set. That's the meaning of complement of a set. Okay? So this is what you are going to have. Okay? I'm just trying to establish likely questions that you can have. So we can also be asked to find A intersection B. A complement intersection B complement. If in a particular question, if you are given a question A and B, and the question is asking you to find A complement, B complement, what you are asked to do is that go and A complement will be elements you have in that universal that are not in A. B complement will be elements that you have at the universal that are not in B. So you can be asked to find, you can have this type of question now. You can be given this question. The question will now say, find A complement intersection B complement. That simply means that you will need to first find A complement. You go ahead and find B complement before you can find A complement intersection B complement. So if you do that, just look at the two. What do they have in common? I think it's only 9 and 10. 9, 10. So in this particular question, A complement intersection B complement is what you have on the board. So this is what you have on the board. Okay, that's what you have on the board. Okay, I think I've made some definitions. Then I also want to say this. You know, we have set of numbers because most of the time you just hear about natural numbers. People doesn't know what we are talking about. You talk natural numbers, integers. Let me just go through set of numbers. Then I will introduce question. There are 6 set of numbers. Okay, the first one are called the natural numbers. Natural numbers, but you might have seen something like this. Up to infinity. Natural numbers are the positive whole numbers. They are the first set of numbers. 1, 2, 3, in that order. So they are the positive whole numbers. This is a particular set of numbers. They are called natural numbers. Natural numbers. Then there's another one called integers. You must have heard about this. That one is denoted as this is the symbol for integers. They can give something like this. Say where y is integers. You should know what it means. It simply means that you can have from minus infinity up to, if you want to truncate, let me say this, if you want to truncate any set, just put command then 3 dots, dot, simply means and so on. So I may decide not to put this. If you want to truncate a set, just put command dot. It simply means that and so on. -1 is 0, 1, 2, dot. So in case of set of integers, it has positive whole numbers, it has 0 and negative whole number. So set of integer is wider than set of natural number. Natural number, they are just the positive counting numbers, positive whole numbers. When it comes to integer, that one is bigger than natural number. That one has 0, it has negative whole numbers. Okay, so this is a subset of this. Natural number is a subset of integers. Okay, integers is bigger than natural numbers. There's another set of numbers called rational. The rational numbers. So what are natural numbers? The symbol for rational number is Q. We use Q to represent rational numbers. There's no way to know this. So rational numbers simply means numbers that can be that can be written in form of fraction, a over b. These are numbers that can be written in form of fraction, a over b, where b must not be equal to 0. Okay, so the set of rational numbers, that one is also bigger than integers. In this case now, we have dot dot dot. We can have -2, -3 over 2, -1 is 0, half, 1, 2, dot dot dot. Okay, integers, in case of set of integers, we have either proper fraction or improper fraction. It involves fraction, but the denominator must not be equal to 0. Once the denominator is equal to 0, that fraction becomes undefined. Okay, that fraction becomes undefined. We have to note that fraction becomes undefined. We have to note that. So this is the third set of numbers. This is the first set of numbers: natural, integers, rational. Okay, these are rational numbers. This one is bigger than this. This is bigger than this. So we say natural number is a subset of integers, while integers is a subset of rational numbers. Okay, these are the first three. Then we can go ahead and define another set of numbers, which is called number 4. They are called irrational numbers, because when you check past question, for those that treat past question, they will be familiar with all this that I'm talking about. Irrational numbers, they are denoted as IQ. So these are numbers, though at times they can be written in this form, but because of this number, that's why we have the concept of surds. Surds, we are still going to talk surds. Surds are irrational numbers. Okay, because of this set of numbers, that's why we have this concept called surds. So let me just give an example of irrational number, e.g., where we have square root of 2, square root of 3, pi, exponential. These are examples under irrational numbers. We have surds as a concept, as a topic in mathematics, because of irrational numbers. Okay, these are the fourth set of numbers. Then the fifth set of numbers are called the real numbers. The real numbers. Then that is the largest number that you guys can do at the elementary. The real numbers, any number you can think of in the recess under this. So the real number simply means rational number union irrational number. So any number you can think of is under this real number. So at your level, you can only talk about real number. Okay. Okay. Then the last set of number, you can only know this when you get to university. They are called the complex numbers. So we are not going to talk about anything about this. So it's denoted as C. It simply means A plus IB. Okay, these are complex numbers. You don't need it. Now, by the time we get to higher institution, they talk about that one. Where this is called the real parts. Here it's called the real parts. The B is called the imaginary parts. So I can only give you an example on this. Let me just give you an example. One example of this irrational number, of this complex number is that if you have to find the square root of -4, it is not possible. You cannot find the square root of -4. The calculator is going to give you error. It's not possible to find the square root of negative. So the only thing you can do here, just split it. Say this is square root of 4 times -1. Okay? Then this will be square root of 4 times square root of -1. What's square root of 4? Square root of 4 is 2. Multiplied by square root of -1 is I. When it comes to complex number, you don't need to know it now. Then the value will be 2i. You can only get the result in the complex sense, not in the real sense. So you cannot solve this. So this complex number is when you get to university. So let's forget about that. So that's about set of numbers. So you can only focus on real number at your level. So let me now take example under sets. Since I now know that you understand all this. So let's take example under sets. Let's take example under sets. Okay, let's take this example under sets. Example where we have A, B, and C are subsets of the universal set U, such that U, the universal set, is equal to 0, 1, 2, dot 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 12. Okay. Okay. Then full stop. What is A? A is equal to S such that is 0 less than or equal to x less than or equal to 7. You can have something like this. So then B is equal to B. Okay, they start to list out B 4, 6, 8, 10, 12. Okay, C is equal to 1 less than Y less than 8, where Y is a prime number. Prime number. So the question, these are the questions. The question says draw a Venn diagram. Okay, I'll use this Venn diagram, question to explain Venn diagram to illustrate the information given above. Then the big part of the question is to find Roman figure 1, the first one, B union C, all complements. Then Roman figure 2, B Roman figure 2, we have to find A complement intersection B intersection C. This is 1998 question number 1, theory. So if you check your past question, you are going to get this question from 1998 question number 1, theory. So this question is 1998 question number 1. So look at the inverser is defined from 0 to 12. Look at A. A is X such that from 0 to 7. Look up. This is simply means less than or equal to. Then I can rewrite A. These are the elements of A. Because of this less than or equal to, 0 is part of this set. Okay, so A will be 0, 1, 2, 3, 4, 5, 6, 7. So that is A. I've done the listening there. S such that 0 is less than or equal to S, less than or equal to 7. So if 0 is less than or equal to S, it still means S is less than or equal to 0. 0 will be part of that set. 7 also be part of, because it's less than or equal to B. We have it there, so we don't have any problem. What about C? Look at C. C is 1 less than Y, less than 8. So what are the elements that we are going to get in Y? The elements that we are going to get in this Y, we consider two things now. This C, the element of C will not be, I want to list it out. Where Y is a prime number. What are prime numbers? Prime numbers are numbers that are divisible by 1 and itself. Okay? So in this case now, 1 is not part of this set. 1 is not a prime number. Because for you to have a prime number, 1 must be there and that number. So 1 is not a prime number, but 2 is a prime number. Because 2 is divisible by 1 and itself. So the first element here is less than 1. So 1 is not part of this. So the first element will be 2. 3 is also a prime number. 3 is a prime number. 3 is also a prime number. 4 is not a prime number. Because 1 can divide 4, 2 can divide 4, and 4 itself can divide 4. So 4 is not a prime number. So we are not going to put prime number. We are not going to put a prime number. Okay? And then 4. 5 is a prime number. 5 is a prime number. 6 is not a, because 2 and 3 can divide 6. Then 7 is a prime number. So these are the elements that we can have. These are the elements that we can have. We were just supposed to study 10 years back. My people, what I'm trying to do is that I just want to use this to explain. Forget about the year. Just have understanding. This is a general revision class. So anything that can come out, just get the idea of what we're talking about. That's what we're trying to say. So the element of C will be 2, 3, 5, 7. Okay? The first one, draw a Venn diagram to illustrate this information. Okay? Now, this is the information. We are asked to draw a Venn diagram. So, what is Venn diagram? Venn diagram is just the diagrammatic representation of a set. This is A. This is A. Here is A. When you talk about Venn diagram, it's when we represent the set in form of diagram. That is Venn diagram. So this is C. This is C. C is equal to this. I want to write everything at one place. B is equal to, what are the elements that we have in B? B is 4, 6, 8, 10, 12. 4, 6, 8, 10, 12. Okay. So Venn diagram. So the inverser is represented by a rectangle. So this will represent the inverser. So is that we use a square or rectangle to represent the inverser in a Venn diagram? Then all the subsets, we are going to represent this as a circle. They will be subsets. Okay? They are part of the inverser. So that's how we represent the Venn diagram. Now let's look at this question very well. A. This is A. Let's say this is A. What are the elements that we have in A? From 0 to 7. Look at C. C. All the elements in C, they are also in A. 2, 3, 5, 7. 2, 3, 5, 7. That simply means that C is inside A. We are going to have C, which is 2, 3, 5, 7. C is inside A in this question. 2, 3, 5, 7. Then what are the leftover? 2, 3, 5, 7. We just write the leftover outside. 0, 1, 4, 6. So this is A and C. Then B also have 4 and 6. So B and C will overlap. B and C will overlap. This is B. So this is 4 and 6. Then we have 8, 10, 12. So this is the diagrammatic representation of that question. This is the Venn diagram to that question. Oh, okay. If y is greater than or equal to 8, then if y, then what you're trying to say is that y such that 1 less than or equal to y less than or equal to 8. And it being, we don't have condition that y is a prime number. 1 will be there and 8 will be there. But even if y is not a prime number, this 1 and 8 will not be there because it's just less than. But if y is greater than or equal to, we are going to consider 1 and 8. Okay? We are going to consider 1 and 8. If y is it greater than or less than? If y is greater than or equal to 8, is it less than we are talking about or greater than? Please, I didn't get the question. If y is greater than or less than, what are you trying to say? Sorry, I mean if, okay, less than or equal to 8. Yes, if y is less than or equal to 8. Yeah, if y is less than or equal to 8. In this case also, 1 and 8 will not be there because 1 and 8 are not prime number. 1 cannot be a prime number. For you to talk about prime number, there are two numbers involved. 1 and any other number. Prime numbers are numbers that are divisible by 1 and itself. So 1 cannot be a prime number. Then in case of 8, 8 is not a prime number because many numbers can divide 8. 1 can divide 8, 2 can divide 8 without remainder, 4 can divide 8, and 8 itself can divide 8. So even if it's less than or equal to, this is what we are going to have. Because 1 is not a prime number, 8 is not a prime number. Okay? But that it being the condition of y being a prime number is not there. And we have less than or equal to, we are going to include 1 and 8 in that set. So thank you. Thank you. So this is the first part of the question. Then the second part says we should find B Roman 1. We should find B union C complement. Look at, we cannot just go ahead and find B union C complement. We first find B union C. So once we know the value of B union C, then we now find the complement. So what is B union C? B union C is equal to, let's find the element that are common between B and C. Element in B or C or both. That will be 2, 3, 4, 5, 6, 7, 8, 10, 12. So B union C are these elements. Then what is B union C all complements? B union C complements are the elements that we have at the universal that are not here. Complement simply means elements that we have at the universal that are not there. So in this case now, B union C complement will not be, 0 is not there, 1 is not there, 1 is not there, 9 is not there, and 11. So B union C complement will just be 0, 1, 9, and 11. Okay? 0, 1, 9, and 11. Then the question, the second part of the question says we should find A prime intersection B intersection C. Okay? So A prime intersection B intersection C. So what is A prime? Let's look at what is A prime. A prime are the elements that we have in the universal that are not in A. That would be A prime would be, A is from 0 to 7. That would be 8, 9, 10, 11, 12. Then what is B intersection C? B intersection C, do they have anything in common? B and C, nothing. B is empty, or is that use this symbol. Therefore, A prime intersection B intersection C will be empty. So that will be empty because they don't have anything in common. So that will be empty. Nothing in common, so it will be empty. Okay? That will be empty. So let's take note. That will be empty. So we take note of that. So please go through. Just go through your past question. There are so many questions, other sets. Just go through your past question. So because of time, we cannot take more than this. So I will move to another topic. I will move to another topic. I'll move to another topic. I'll move to another topic because of our time. Okay, so I'll move to another topic. So somebody suggested Surds the other time. So I also saw matrices there. Surd matrices, circle geometry. So let's move to another topic.
All right, thank you very much, our dear students, joining us across the globe. We really want to appreciate, yes, we are moving on to another topic now. We really want to appreciate your time, and we so much believe this will definitely, show in your results. But we just want our teacher to relax for just few minutes, and let's hear from the state chairperson of the Mathematical Association of Nigeria. That is in person of Pastor Gbemisola Orekoya. She's the one that is doing this. Don't worry, your student. We are still going to touch circle geometry. We definitely touch matrices and calculus. We'll do that. We are all here together here, provided you are ready to stay and make use of this. So let's hear from the state chairperson of the Mathematical Association of Nigeria to charge us more. She's the one that do this for us, and we really want to appreciate our mommy. Thank you very much. Over to you, Mrs. Pastor Gbemisola Orekoya. You can unmute your mic and talk, man.
Good evening, my dear brother. Good evening, great Nigerian
Good evening,
students, great mathematicians. Good evening. Thank you so much for our teacher, Mr. Folabi. I want to appreciate you because I've joined and I've seen what you are doing. I want to um, tell our students that if you can diligently listen to things they have said to us today, I'm sure tomorrow's examination is already a job for us. I want to encourage you to keep at it. When you keep solving mathematics, you are far from fear. There will not be any fear in you. And mathematics is very, very simple. Very simple. The only thing you require is appropriate application to every topic. And once we are charged up tonight concerning, I was to them in the number everything very beautiful. The sex theory, very beautiful. I want to appreciate my teacher once again for taking out time diligently explain every detail and what it requires. My wonderful student, I want to give it to you for participating tonight because I know that with all that we taught today, and when you relax a little in reverse back before you start your exam tomorrow, I'm sure that you come out in flying colors. Thank you so much, Dr. Kayode. I want to appreciate you for giving us the edge in this. And Mathematical Association of Nigeria, the state of time, is involved in ensuring that our students come out the best in mathematics. And we relieve the fear that they all have in mathematics. And I'm sure consistently will continue on this. And like Mr. Falaka said, if you are reacting jam and we are doing this weekly, I'm sure everyone that will put mathematics in their subjects for jam will find out that mathematics is very simple. Thank you so very much. I want to appreciate it and I wish you all the best in your examination. God bless you. Thank you for Kayode. I appreciate it. And all our teachers that are on ground, I want to say thank you very much. Thank you. We appreciate you. And our efforts, God will crown it with coming success in the mighty name of Jesus. Thank you so much. God bless you. Have a wonderful evening. Thank you, Doctor.
And I thank you
God
very
bless
much.
you.
That is the state chairperson of the Mathematical Association of Nigeria. That's Pastor Gbemisola Orekoya. We really want to appreciate you because we know that every year the Mathematical Association of Nigeria, Ogun State chapter, always deem it fit to make sure that we reach out to our students, especially students in SS3, at the eve of the wax exam, that is the SSC examination. We normally do this. We really want to appreciate our whole wonderful man, that is Dr. Oladele Ogunfowote, the founders of the Toide online class. He has been doing this for us for over close to 2 hours now. Close to 2 hours. The Mathematical Association of Nigeria Ogun State chapter really appreciate this, and we thank you, and we pray for more strength from above for you in Jesus' name. We also want to appreciate those that are on the queue too. We have other teachers that are also in support of this. We want to appreciate our wonderful friend from the northern part of the country, Tamboa. He has been doing this for us since he has been sharing all what you have been putting online about this, pulling, gathering more students to come and join this virtual revision. We want to appreciate a same Nofu, those people that are joining us. We also want to specifically appreciate the Mathematical Association of Nigeria for giving us this platform to reach out to our students this time around. Thank you all. And we are moving into the second section of the class now. Over to you, Doctor.
Okay, so we are welcome back to the second section. So you are welcome back to the second section. So let's start this second section with simple equations. Simple equations and variations. Simple equations and variations. So let me start with variations. Of course, I want to believe that we are familiar with variation. So there are 4 types of variations. The first one is called the direct variation, which I know we are all familiar with. For instance, if we say y is directly proportional to x, okay? So this is the sign of proportionality. So if y is directly proportional to x, we cannot do anything until we change this sign of proportionality to is equal to, that is, and if we want to remove this, we are going to say that y is equal to kx. So for us to be able to change this sign of proportionality to is equal to, it must we have to introduce a constant. We introduce a constant, which is called the constant of proportionality. So in this case now, this is what we are going to have. So for us to be able to do this, we know the value of, let's say, if when y is 4, x is equal to 2. So by the time we substitute this, 4 is equal to k multiplied by 2. So we divide both sides by 2. So k is equal to 2. That's what we are going to get. K is equal to 2. That's what we are going to get. So by the time we substitute the value of k back to this equation, we are going to have y is equal to 2x. And this is what is called the law. This is what is called the law of variation. This is what is called the law of variation. So under variation, when we introduce equality sign and we introduce the constant of proportionality, but by the time we substitute for the value of the variables under consideration, and we're able to get that constant of proportionality, once we substitute the constant of proportionality back to that equation, it is called the law of variation or equation connecting. Is that you call it law of variation or equation connecting the variables? So once we are able to establish that, then we will be able to solve any problem under that. So this is the first type of variation that we have, direct variation. After this, we have what's called the indirect or inverse variation. Of course, that one is also is similar to this. When we say y is inversely proportional to x. So this is almost the same thing, just that it's the reciprocal of the first one. So y will be equal to k over x, and of course course, if you introduce this, so k will be equal to yx. Okay, so this is inverse variation. Then the third one is when we talk about the joint variation. Under the joint variation, we are going to have the combination of direct and indirect variation. For instance, where we have y is proportional, directly proportional to x, and inversely proportional to z. So this simply means that y is directly proportional to x and inversely proportional to z. So by the time we introduce constant of proportionality, we are going to have y is equal to kx all over z, and that's what we are going to get here. So this, in this case now, this is the third type of variation, which is called the joint variation. So the first three types of variation, we are going to have just one constant of proportionality. But the last type of variation is called the last one is where we are going to have two types. We are going to have two constants of proportionality, and that variation that will be the fourth variation. You know, the first, second, and third. This fourth one, we are going to have two constants of proportionality. So, for instance, we are going to have, let's say, A, partly constant. We have something like, and partly varies as Y. We have something like GY. So, we are going to have where B and D are constants. So this is the type of variation in which we are going to have two constants of proportionality. So I just want us to note all this. Let's note all this. When it comes to variation, we are still going to consider question under this. We are going to consider question under this, but let's just note that there are four types of variation: direct, indirect, inverse variation. Then we have joint variation and partial variation. Under partial variation, that's where we have two constants of proportionality. Then before I will introduce my question, let me talk briefly on making a particular variable a subject of formula. That is, at times we talk about subject of formula, making a particular variable a subject of formula. What is required when we are asked to make a particular variable a subject of formula in a particular question? For instance, if you have this type of problem where we have C is equal to square root of PQ all over R minus R squared Q. Look at this is a particular question. This question now is 2011 question 2, the theory part. This particular question. In this question, we are asked to make Q the subject of formula. This question is 2011 question 2, the theory part. In the year 2011, question 2. Look at this. When we want to make a particular variable, subject of formula, what do we do? Let's take an example on this before we go to variation. In this type of problem now, what do we do? Under making a particular variable a subject of formula, what we try to do is that we try to rewrite the equation using our knowledge of mathematics, so that what we want to make the subject of formula, we bring it to one side, then we transfer the other ones to the other side. So we don't really have any particular formula or approach to it. It depends on the nature of the question. You look at the question. For instance, look at this question on the board. C is equal to square root of PQ, P multiplied by Q divided by R minus R squared Q. We want to make Q the subject of the formula. How do we do that? What we should be thinking of is how do we transfer every other variable to one side, then we have Q at one side. Then whenever you have this type of problem and you have something like square or square root, the first step is that you first eradicate square root, because when you have square root, you won't be able to do anything. So in this case now, we are going to square both sides. So once we square both sides of this equation, we are going to have t squared. Once we square both sides of the equation, we are going to have t squared. Here will be t squared will be equal to, if I take the square root of this right hand side, square will cancel square root. It will be PQ all over R minus R squared Q. So we have been able to establish a particular point there. So we've removed the square root. How do we remove it? We take the square of both sides. Square will take care of square root. That's the first step. Then at the right hand side here, I can try to find the LCM. So here the LCM will be the R. So I'm going to have PQ minus R squared, PQ minus R cubed squared, R cubed Q. That's what I'm going to get. 1 in R is R times R squared is R cubed. Then this is T squared. Okay? We want to make Q solve the formula. So I want to try and bring out Q at that right hand side. Okay, from here I can cross multiply. Once I cross multiply, I'm going to have PQ minus R cube squared. R cube Q to be equal to T squared R. Then at this stage, I can bring out Q. Q is equal to P minus R cube to be equal to T squared R. I can divide both sides by P minus R cube, P minus R cube. This will take care of this. Automatically now, we have been able to make Q the solution formula, which is equal to T squared R all over P minus R cube. And that is what we are asked to do. So under making a particular variable a subject of formula, what we normally do is that we look at the question, then we try, we are going to apply our mathematical knowledge to be able to bring that variable to one side, then we transfer every other variable to the other side without manipulation. Like what we have on the board, we are able to bring out the value of Q. We are able to do that, and that is what we are going to get on the board. So we take one more question on this. Thereafter, then I'll take variation, because variation is another important topic in mathematics that we normally have every year. So after variation, I will talk briefly on linear equations, quadratic equation, then we move to Surds. So this is another question. This question is 2020, question 2. This is also a theory question. You can check year 2020, question 2, the theory part. Given that P, in this question now, the question is simple. Just look, it looks complicated, but it's very simple. It's something you can do. Just look at what we are about to do now. Given that P is what we have on the board, the first question says that we should make Q the subject of formula. That's the first question. Then the second question, Roman figure 2, we have to find, correct to 2 decimal place, 2 dp, the value of Q. We have to find the value of Q when P is equal to 3, M is equal to 15, S is equal to 0.2, K is equal to 4, and R is equal to 10. That's what we do. So please, let's start solve this. Once we are unable to do the first part of this question, then we should forget about it. We can't get the second part. It's not possible to get the second part, because if we are unable to make Q solve the formula, we cannot solve this question. So now let's move. We have P to be equal to RK all over Q minus MS raised to power 2 over 3. How do I eradicate this 2 over 3? I can only do that by using the reciprocal of this to multiply both sides. That is what the implication of this 2 over 3. It simply means this 2 over 3 simply means this, what you have here is something as the cube root of, this is the meaning of cube root of RK over Q minus MS, everything all squared. This is the meaning of what you have here. You take the cube root of this, then you square everything. So how do I remove this? What I can only do is that I'm going to take, I'll say P cube. I'll find, this is what I'll do. In this case now, I will do something like this. RK all over Q minus MS multiplied by 2 over 3. That's what we have. Multiplied by 3 over 2. So this will take care of this. That is, I want to find the square root of everything, then now square it. So it will cancel out. At the end of the day, I've been able to establish the fact that P3 all over 2 is equal to RK all over Q minus MS. Then I'll find the LCM here. For me to be able to find the value of Q, I have to find the LCM. Without the LCM, I cannot do that. So if I find the LCM there, this is what I'm going to get. From there, P3 all over 2 will now be equal to, the LCM is Q. That is Q. Then Q here will be RK minus RK. No, I don't need to find the LCM, because once I find the LCM, there will be Q there again. So we don't need to find the LCM. What I will do is, I'll just say PQ. I will bring this, what I have here, I'll bring it to the right hand side. So this will be plus MS will be equal to RK all over Q. Then from here, I can cross multiply so that my Q will now be RK all over P 3 over 2 plus ms. So this is the value. Then what is the implication of this? I can write this. The implication of this is that the implication of what we have on the board is that q is equal to r multiplied by k all over the square root of p all cube plus ms. This is the implication. So this is the value of q. We have decided to make q the formula here. So we can go ahead and solve for the second part of the equation. So what do we do there? What do we do there? We want to find q when p. What is the value of r then? We are given the value of r. The value of r is given as 10. R is 10. R is 10. So we have 10 multiplied by k. K is 4. All over square root of p. P is 3. Square root of 3. All cube plus m is 15. Multiplied by x is 0.2. So we need a calculator here. From here, I'm going to get 40 at the numerator. Then the denominator, the cube root of 3 is 1.732. If I'm not mistaken, that's 1.732. The cube root of this. Then in 3 places. If I take this in 3 places, I can approximate. I want to use approximate. It is not allowed to use approximated value. But in this case now, I want to use approximated value. Or let me just use my calculator to get the actual value, so that we will not use approximated value. You can do that. At least you can do that in your notes. You should be able to do that in your notes. Please try what you have there. So cube root of 3 in 3 places. You should be able to do that. So just write out what you have. So if I do that, I'm going to get 5.196. Then plus, let's find 15 times 3. 15 times 0.2. So this will be equal to 3. So at the end of the day, we're able to get 40 all over 8.196. So Q will now be equal to 40 divided by 8.196. Just cross check. Don't depend on my answer. Cross check and write it and do what you have. 196. So at the end of the day, I'm able to get 4.8804. That is the value that I got. So the question says that we should write our answer correct to 2 decimal place. So Q is approximately 4.88 to 2 dp. So that's what we are going to get. So you should be able to make any variable to the formula, provided that you know what you are doing. So you should be able to do that, provided that you know what you are doing. So that's what you are going to get. So that's that about that. So let's take 1 or 2 examples. Under change of formula, we have so many questions. We have so many questions in the past question. Just try and go over it. Because of time, we will not be able to do much here. So let's take 1 or 2 examples under variation. Let's see this example under joint variation, where we have P varies directly as Q. P varies directly as Q, and inversely P varies as the square of R. That's what we have. So if P is equal to 1, when Q is equal to 8, and R is equal to 2. So we have to find Q when P is equal to 3 and R is equal to 5. This is 2011 question 3 theory. So that's 2011 question 3 theory. So this question is question under joint variation. It consists of both direct and indirect variation. Yes, the use allowed in mathematics. You can bring. You must not write anything. You must not write any other thing there. It is only the formula. It is only. You cannot write any formula. You cannot use that pencil or biro to write anything. but the use of four-figure table. There's what we call four-figure table that we have most of this formula, the statistical formula, all this when we have all this main media mode. So when we have group and non-group data, so there's some formulas there. So it's allowed. Use some formulas, some formulas in physics for those that did dynamics, kinematics. Okay. So now let's look at this question. The question says P varies directly as Q and inversely as square of R and inversely as square of R squared. That is, P varies directly as Q and it varies inversely as square of R squared. It's joint variation between direct and inverse. So we can combine it instead of writing it like this. We can combine this and have something of this nature. So that at the end of the day, we say P is equal to KQ all over R squared. That's what we're going to get. So before we can establish the equation connecting the three variables, we must know K. So once we know K, that will represent the equation connecting the three variables, or what is called the law of variation. So in this case now, we are given P to be equal to 1. P is 1. It's equal to K times Q is 8. Then R is 2. That will be 2 squared. So if I cross multiply, I'm going to have 8K to be equal to 4. I'll divide both sides by 8. 8 will cancel 8. Then K will be equal to half. So since K is equal to half, then P will now be equal to Q all over 2 raised by half squared. You know, K is half, 1 all over 2. So this is the law of variation or equation connecting all the three variables. So once we are able to, without this, you cannot solve the question. But once we are able to establish the law of variation or equation connecting all the three variables, then you can go ahead and solve the question. So the question says that we have to find Q when P is 3. So from here now, what is P? P is 3 is equal to Q all over, then R is 5. We have 2 into bracket 5 squared. So what do we get here? We are going to have 3 to be equal to Q. This is multiplied. 5 squared, 5 times 5 is 25. 25 times 2, that's 50. 50. So if I cross multiply here, Q will be equal to 150. So Q is equal to 150 according to that question. So according to that question, Q is equal to 150. Some people have done that already. So I don't think we need to waste much time on this variation. Probably I should move to another topic because of our time. So maybe I should move to another topic. It seems people understand this variation very well. So let's move to another topic. Then let me go straight to equations. Then in this equation, I'm going to treat about four different concepts under this equation. You know, there are some equations, there are some questions. I'm going to give us the type of question. We have some of this question. For instance, we have linear. There are so many types of equation. We have linear equation. When we have linear equation, the degree is equal to 1. For instance, if you have 2x plus 3, it's equal to 4. The power of x here is 1. So the value of x that we don't get, we have only one value for x. When we have something like x squared plus 5x plus 8 equal to 0, the power of x here, the highest power of x here is 2. So this one is quadratic. The value of x that you are going to get is 2. Then when you plot the graph of this linear equation, when the power of x is 1, the graph is a straight line, either this form or this form. But when you plot a quadratic graph, it's either this form or this form, depending on the value, or depending on the coefficient of the coefficient of x squared. Okay, so that's just introduction. So I'll take one example under linear equation. We'll now go to quadratic equation. Quadratic, probably we use the 3 methods. Then we move from there. So let's take this example. We have to solve this equation. Solve the equation. This question is 2017 question 2. WAEC 2017 question 2. 2 all over 3 into bracket 3x minus 5 minus 3 all over 5 into bracket 2x minus 3 is equal to 3. So the question is 2017 question 2. So let's look at the question together. We want to solve for x. Of course, this is a linear equation, and we are going to get just one value for x. Under linear equation, we know what to do. We are going to get just one value for x. So how do we solve this problem? It depends on how you want to approach it. But I think the simplest method to do here is to find the LCM. This is the same thing as what I have here. I can write it as 2. I can even open up what I have here, all over 3. So that I can open up and say this is the same thing as 2 multiplied by what I have at the numerator. That will be 6x minus 2 times 5, 10, all over 3, minus 6x minus 9, all over 5. Okay? I can have that. It's equal to 3. So if I find the LCM here is 15. So since the LCM is 15, the LCM is 15, I can multiply through by 15 in order to put everything on a straight line. Since I know that the LCM is 15, I can multiply through. Instead of saying find the LCM, I can multiply through by 15. So once I multiply through by 15, I will put everything to a linear equation, to a straight line equation. That is, I will say 15 multiplied by 6x minus 10 all over 3 minus 15 multiplied by 6x minus 9 all over 5 is equal to 3 times 15. Okay, I'll multiply 2 by 15. 3 here 1, 3 here 5. So 5 times 6, this will be 30x minus 50. Here, 5 here 1, 5 here 3. I have minus 3 times 6, that's minus 18x. Minus times minus plus 3 times 9, 27 is equal to 45. So from here, I can do the 30x minus 18x, that is 12x. Minus 50 plus 27, that's minus 23, is equal to 45. Then 12x will now be equal to 45. By the time this one crosses this line, it will be plus 23. So 12x is equal to, this will be 68. So 12x will be 68. 12x is going to be 68. So we have 12x to be equal to 8. If you cancel this, so x will be equal to, can 4 divide this? 4 here, this is 1, 2, 7. So this is 17 all over 3. That's what I'm going to get. So x is equal to 5 whole number, 1 over 3. That will be the value of x. So if you have to find the value of x, that's what we are going to get. The value of x is what we are going to get on the board. So this one is just a linear equation because the degree of x is just raised to power 1. Okay? The degree of x is raised to power 1. So what if we have quadratic equation? Then as I said earlier on, when we have linear equation, the graph is always a straight line. Either this form or this form. The graph of a linear equation is always a straight line. But if you have a quadratic equation, that's when the graph will be curve-like. Then the direction of the graph depends on the coefficient of A. So by the time I introduce now quadratic equation, now you understand some of these concepts. So in case of quadratic equation, I think all of us are familiar with this. Everybody must have heard about this equation. Quadratic equation is the equation of degree 2. That is, the general form of this quadratic equation is ax squared plus bx plus c equal to 0. This is the general form of quadratic equation. We are all familiar with this. All of us. We are familiar with this. Okay? We are all familiar with this. So this equation, the highest degree here is 2x. Then we should say that a must not be equal to 0. Because once a is equal to 0 here, this equation becomes linear. If a equal to 0, this one will vanish. And once this one vanishes, we have reduced the equation to linear equation. So when we write this, we must state this statement that a must not be equal to 0. So this is the general form of quadratic equation. And if you want to solve this quadratic equation, we have about 4 methods to use here. The first method is what we call the factorization method. Just comment if you don't need to talk about factorization method, just let me know. The second one is called the completing the square. We can use completing the square method. Completing the square method. This is the second method. Then the third method is when this completes here, when we use the formula. Some people refer to as almighty formula, the quadratic formula. We can also solve it using the formula. Then the fourth method is where we can solve it graphically. Graphical method. So when we solve it graphically, the solution will be the root of the equation. So the root of the equation will be the solution. So these are the 4 methods that we can use to solve this quadratic equation. These are the 4 methods. But at times, when you check past question, at times the examiner will compel us to use. I've seen it in the past question where they are asked to use completing the square method to solve quadratic equation. So if you have to use completely square method and you decide to use factorization method, you score 0 because you don't follow instruction. But if you are just given the question, you are not compelled to use any method. Just look at the question very well and just pick your choice. Of course, without this one is out of it without graph. If you don't have graph, you cannot solve it using graphical method because quadratic graph, you can only use graph to solve quadratic equation using graphical method. So once you don't have graph, forget about this last method. You cannot solve it. But you can solve it. But you can solve it using the three methods. Then another thing I want to say is that this first method, factorization method, has its own limitation. It's not all quadratic equations that are factorizable. So let's take note. There are some quadratic equations that you can never solve using factorization method. But these two methods are the best. You can use the formula method to solve any problem, any given quadratic equation. This formula method will solve it. Then if you know how to use completely square method also, you are on the safer side. Okay? Factorization method is good, but it has its own limitation. There are some quadratic equations that you cannot factorize, that are not factorizable. Once you have a quadratic equation that you cannot factorize, then you won't know what to do. There will be problem. And once there is problem, you don't. So to be on the safer side, it is good to know all the method. Then if you come across any problem, you will know what to do. Okay? So I want to advise that we should try. Okay, there's a particular question here. There's a particular question here. It is 1995, question 7. The question says that use the method of completing the square. Find the root of the equation. Correct to 1 dp. Look at that question. 1995, question 5. In this question now, there's nothing that anybody can do. So once you don't know the complete, and it's under compulsory question. So once you don't know what to do, then if you say, oh, I don't want to use completing the square method, I want to use formula. Of course, you will use it, but just that at the end of the day, you can still get 0 since you decide not to follow the instruction. So if you look at this question now, the question says that using the method of completing the square method, this complete the square, find the root of the equation. This is the equation: x squared minus 6x plus 7 is equal to 0. So this is a quadratic equation. Can we factorize this quadratic equation? Is it possible to factorize this quadratic equation? If you want to use factorization method, this is what you consider. You consider the coefficient of x squared and this constant, you multiply it. So in this case now it will be 7. You now think of two factors of this 7. That either when you add the factors together or you subtract, it's going to give us minus 6. Okay? You know, minus, what are the factors of 7? It can be 1. The factors of 7 will be 1 times 7, 7 times 1. I think that's all. Then minus 1 times minus 7, minus 7 times minus 1. So if you look at this now, none of this is going to give us what you have here. None of this factor will give us what you have here. Because if I pick this, so I'm going to get minus 7 minus 1. It's not going to give me what I want. So in this type of problem now, we may not be able to use quadratic. We may not be able to use, in this type of question now. Okay, somebody will say we can factorize. Okay, then now let's factorize and see. Let's factorize and see. So what are the factors that we are going to use? What are the factors? Just tell us the factors. The factors that we are going to use. Because the factors will be 1 times 7 is 7. So tell us two factors that 7 positive 7 that will give us minus 6. Just tell us two factors that will give us minus 6. Here. So in order not to waste our time, I want to use completely the square method here. So I will use this completely the square method. No, completely the square method. If you apply completely the square method on this general formula, that is how we got that formula, which is x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So if you follow the step that I'm about to do now, you'll be able to follow the step that I'm about to do now on this general form of quadratic equation. You are going to get this formula. So the method of complete square method was used to generate that formula. Okay? You cannot use minus 7 plus 1. If you use minus 7, The constant here is 1. 1 times 7 is 7. So you cannot use minus 7 plus 1. You can't do that. Because this is 1. Where do you get your minus? The factor will be the coefficient of s squared multiplied by constant. That's the factor we consider. That's 7, not minus 7. So don't forget about that. Look at the method I'm about to use now. This completed the square method I'm about to apply here. If you apply it on this general formula, you are going to get this quadratic formula. That's what I'm trying to say. Just follow the step, then apply it. Just follow the step and apply it. You are going to get, if you apply it on this now, you are going to get this formula. That's what I'm saying. But we don't have time to show that. So let's just go straight to the question. So in this case now, this is s squared minus 6x plus 7 equal to 0. So if you want to apply completing square method, there are 5 steps involved. The first step is that you should make the coefficient of x squared to be equal to 1. But in this question, the coefficient of x squared is already 1. The coefficient of x squared is already 1. So the first step, we are not going to apply the first step yet. The first step is that you make the coefficient of x squared 1. For instance, when you have ax squared plus bx plus c equal to 0. If I want to apply complete the square method here, I'll first divide through by a. I'll divide through by a. So that this will cancel this. I will have x squared plus b all over ax plus c all over a is equal to 0. So that's the first step. But in this given question, the coefficient of x squared is already 1. So I don't need to apply the first step. Okay, that's what I'm trying to say. Then the second step is that you transfer the constant to the other side. That is step 2. X squared minus 6x is equal to minus 7. First step, make the coefficient of x squared to be equal to 1. Second step, transfer the constant to the other side. Then the third step, consider the coefficient of x, which is minus 6. Minus 6. Divide it by 2 and square the result. The third step, consider the coefficient of x squared. And consider the coefficient of x. In this case now, the coefficient of x is minus 6. Divide it by 2 or multiply it by half, then square the result. If you square the result, we are going to have, in this case now, we are going to have minus, that will be 36 all over 4. That's what we are going to get. So this is the third step. The third step, consider the coefficient of x, divide it by 2 and square the result. Then step 4, add the result to both sides. Add the result to both sides. If you divide it by 2, you are going to get 3 here. In this case now, if you divide it by 2, we are going to get, this is what you get. You get minus 3, I mean. You are going to get minus 3, right? You get minus 3. Minus 3 squared. Okay? And that's equal to 9. So you add the result to both sides. So if you do that, you are going to have x squared minus 6x minus 3 all squared is equal to minus 7. Minus 7 plus minus 3 all squared. Look at the left hand side, you don't need to expand. The right hand side, you can use the expansion, you can use the result here to be 9. But at the left hand side, just divide the coefficient of x squared by 2, square the result. That's what you are going to use. Okay? So in this case now, how do I now rewrite this one? This is what I will do. Look at the board. This is x squared, this is minus 3 squared. I'll just say x minus 3 all squared. If I expand this, I'm going to get this. So at this point now, once you apply the step 4, x squared minus 6x minus 3 all squared. Don't expand at the left hand side. Don't expand the results. At the left hand side, you can just write the final answer. At this left hand side, just pick x, which is x squared. Pick x. What you have inside this bracket, you pick it minus 3 all squared. If you expand this, you are going to get this. Then this will be equal to minus 7 plus 9. Here will be 2. So from here, you just take the square root of both sides. Step 5, take the square root of both sides. When you take the square root of both sides, plus or minus will be in front of square root. Square can cancel square root. You are going to have x minus 3 to be equal to plus or minus square root of 2. Okay? Then from here, you transfer this to the other side. So you have x to be equal to, this is minus 3 to be equal to 3 plus or minus square root of 2. So x will now be equal to 3 plus root 2 or 3 minus root 2. That's what we are going to get. So x will now be equal to 3 plus square root of 3 is 1.414 or 3 minus 1.414. That's what you get. So x will now be equal to 4.1414 or when you subtract 3 from this, here will be 6, here will be 5. When you subtract, this is 3, 0, 0, 0, 9, 6. Here will be 9, 8. Here Here will be 5. That will be 1.586. So that's what you are going to get. That's what you are going to get. So if you follow the step, diligently, then you are going to get what you have on the board. So if you follow the step diligently, you are going to get what. This is how to apply complete the square method to solve quadratic equation, and that's what we are going to get. So as I've said earlier on, completing the square method or formula method is the most important method when it comes to quadratic equation. They can solve any given quadratic equation. Look at what we got here. So if I don't want to use completing the square method that we have applied here, you can go ahead and use formula method. But in that question, you must is a must to use this completing square method. So if you want to apply formula method here, just compare the two. Ax squared plus bx plus c equal to 0. What is a here? A is equal to 1. Okay. B is equal to minus 6. C is equal to 7. That's what we are going to get. A, B, C. That's what we are going to look at. That's what we are going to get. So what is the formula? S is equal to minus B minus square B squared minus 4A all over 2A. So just substitute. What is B minus 6? Just say minus into bracket minus 6 plus or minus square root of B minus 6 squared minus 4 times 1 times 7 all over 2 times 1. So here we are going to have 6 plus or minus square root of 36 minus 4 times 7, 28 all over 2. So here we are going to have 6 plus or minus square root of 8. Okay? Square root of 8 is 2 root 2. 2 root 2 all over 2. So if you rewrite this, 2 can divide this, you are going to have 3 plus or minus root 2. You realize that we get the same answer. Either use formula method or complete square method, we are still going to get the same answer. Okay? That is that about completing the square. Minus 7 did not become excuse me. No, I said you had the result to both sides. It is minus 3 squared that becomes 9, not minus 7. It is minus 3 squared that becomes 9, not minus 7. Okay? It's not minus 7. So please just go through the steps. Okay, that's what we are going to get. So that's that about quadratic equation. So the graphical method, let's leave that until we get to graph. Let's suspend that until we get to graph. So we can talk about Surds now. People requested for Surds. So let's talk about Surds. Let's talk about Surds. So the concept Surds comes to realization as a result of irrational numbers. Irrational numbers such as square root of 2, square root of 3, square root of 5, square root of 11. You cannot find the square root of all this and get a whole number. Okay, you can't get a whole number because these are not perfect square. Okay, so when you talk about Surds, there are some rules that we applied. I've told us the reason why we have Surds as a result of these irrational numbers. That's why we have the concept Surds. So, but because before we can talk about Surds, there are some rules that rules or laws that guide Surds. The first rule is when we have square root of x multiplied by square root of y is same thing as square root of xy. Is the same thing. Okay. Another one is that if we have square root of x divided by square root of y, it's the same thing as square root of x all over y. So, but we should note that square root of x plus or minus square root of y is not the same thing as square root of x plus or minus square root of y. In case of multiplication, it's possible. In case of multiplication, it's possible. In case of division, it's possible. But in case of addition and subtraction, it is not possible. You cannot say square root of 2 plus square root of 3 is not the square root of 5. No, it's not possible. We have to do it separately. Okay? It is not possible to have that. It is not possible to have something of such when it comes to addition and subtraction. So these are some of the rules that guide Surds. So I want us to check. I want us to check questions under Surds. Then under Surds, let me just explain Surds generally before we take question. So there's what we call similar Surds. Similar Surds simply means surds that can be added or subtracted from each other. Similar Surds, for instance, if you have square root of 2 plus square root of 8. No. So, for instance, if you have square root of 8, can we simplify this sort? Can we rewrite this? Can we rewrite this square root of 8? Yes, it's possible. This can be written as square root of 4 times 2. Okay? Then, from the law of sorts, this is written as square root of 4 multiplied by square root of 2. What's square root of 4? That is 2. Then, multiply that with 2 with 2. So, invariably, square root of 8 is same thing as square root of is 2 root 2. Square root of 8 is same thing as 2 root 2. Square root of 8 is same thing as 2 root 2. So if you have 2 and if you have square root of 2 and we have 2 root 2, these are similar surds. Why are they similar? They have square root in common. So you can add or subtract similar surds. You can only add or subtract similar surds. Let's get that clear. I can add these two together now. This is what I'm saying. If I say square root of 2 plus 2 square root of 2, no, in front of this square root, there's 1 here. So 2 plus 1 is 3. So this is going to give me 3 square root of 2. That's what I'm going to get. So these are similar surds. We can only add or subtract similar surds. Okay? But it's not possible to say square root of 2 plus square root of 3. We cannot add these two together. It's not possible. Why? Because they are not similar. You cannot say square root of 2 plus square root of 3 and say this is square root of 2 plus 3. No, it is not. So you can't say this is square root of 5. It is not. They are not similar. You can only add or subtract similar surds. You can only add or subtract similar before we can add surds. So just like when we have 2x plus 6x. You know, this is x, this is x. You can say 2x plus 6x. You can say this is 8x. But if you have 2x plus 3y, can you say this is 5xy? It does not make sense. Just view it in this form. X. So it goes. When you now have xy, you cannot have the two. This is how you leave it. We cannot simplify further than this because they are not similar. So in case of surd also, you can only add or subtract similar surds. If they don't have, for instance, you cannot say square root of 2 plus square root of 3 and say it's the same thing and add the two. No, it's not possible. Okay? You can't do that. Then that is that about similar surds. Then there's what you call conjugate surd. What is the meaning of conjugate surd? For instance, if you have square root of 3 plus 2, the conjugate of this surd simply means you change the sign from plus to minus. The conjugate of this will be square root of 3 minus 2. These are conjugate surds. Conjugate simply means change the sign. If it is plus, change it to negative. If it is negative, change it to plus. For instance, if you have square root of 5 minus square root of 3, what is the conjugate of this surd? The conjugate of this surd is square root of 5 plus square root of 3. So that's the meaning of conjugates. Conjugate simply means, okay, but why do we need the knowledge of conjugate? The knowledge of conjugate is needed if you want to do what is called rationalization of surd. Rationalization simply means when we have surd in form of fraction. That is why we need the knowledge of conjugate of a surd. Conjugate simply means we need knowledge of conjugate of a surd when we want to do rationalization, when we want to rationalize the denominator. That is the reason why we need the knowledge of conjugate. If the question says find the conjugate of this surd, what the question is trying to say is that if the question is positive, change it to negative. That's its conjugate. Okay, that's the conjugate of a surd. So with the little explanation, I want us to consider questions from past questions. Let's take questions from past questions and we apply the knowledge. At least this little explanation, we should be able to do one or two things. Okay, let's see. I want us to consider question 10, theory part 2013, where we evaluate without using calculator or tables. Evaluate without using calculator or tables. Series square root of 3 into bracket, 2 square root of 2 of 3 minus square root of 12 all over 6. Okay, that's the question. This is why question 2013, question 10. Okay, look at what we are asked to do. We are asked to evaluate this. So we are asked to evaluate this. So what do we do here? What do we do here? We have to evaluate this. How do we approach this? So let me say this. So we don't have a particular approach to any question in mathematics. So you are the one that will determine how you want to move. As long as you don't manipulate, you follow the steps, we are still going to meet at the same point. So we don't have a particular approach to any problem in mathematics. Just know the rules, know the laws, apply the laws appropriately. At the end of the day, we are still going to get the same result. So I can approach this question with, we can approach this with diverse methods. If you like, you can first open up, first multiply through before you simplify. Or somebody might decide to say, okay, let me leave this. Let me first find the STM of what you have inside the bracket before I multiply. We are still going to get the same answer. So what I'm trying to say in essence is that we don't have a particular approach to any problem in mathematics. Just follow the approach that you think it is appropriate for you. And at the end of the day, we are still going to get the same answer. So let's look at this question. So let's look at the approach that I want to apply. So I might decide to say, okay, let me first open up. That is, I can say this is equal to 3 times 2, 6, all over square root of 3 times square root of 3. No, that's square root of 9. And square root of 9 is 3. That will be 3. Minus, I will say 3 times square root of 12. That is 3 square root of 12. All over square root of 3 times 6. That is 6 square root of 3. Look at the approach that I decided to use. I'm decided to do it with another method, but because of my time, I'm decided not to do it. If you don't want to do it this way, you can decide to focus on this, what we have inside the bracket. Find the SCM, simplify before you do your multiplication. We are still going to get the same answer. That's what I'm trying to say. Then in this case now, 3 here 1, 3 here 2. I'm going to have 2 minus 3. I can rewrite 12. Square root of 12 is same thing as square root of 4 times 3. From the law, this is square root of 4 times square root of 3. What is square root of 4? 2. That will be 2 root 3. So the 12 that I have here, I can change 12 to say 3 times 2 root 3. 12 is same thing as 2 root 3. All over 6 root 3. Look at it though. Root 3 can cancel root 3. 3 times 2 is 6. 6 will cancel 6. I'm going to have 1 here. So I'm going to have 2 minus 1. The answer will be 1. So the final answer will be 1. Look at the approach. The final answer will be 1. We don't have any approach here. But, or let me use another method. Let's approach it with another, so that I want to establish the fact that we don't have a particular approach in mathematics. You look at the question and follow the approach that is convenient for you without manipulation. I must emphasize, without manipulation. Look at, I got one here. So let me do it in another way around. I will say this is 3 all over square root of 3. Into bracket, I want to concentrate on this bracket now. What I have inside the bracket, I want to find the SCM. The SCM here will be 6 root 3. Okay? Root 3 in root 3. I will be left with 6. 6 times 2, that is 12. Minus 6 in root 3. 6 in 6 root 3, I will have root 3. Root 3 times root 12. 3 times 12 is 3 times 12 times 3 is 36. That's root 36. Root 36. Of course, root 36 is 6. So that I will have 3 all over root 3 to be equal to 12 minus root 36 is 6. That's 6 all over 6 root 3. That's what I have inside this bracket. Then here I'm going to have 3 all over root 3 into bracket 6 all over root 3. Okay? 6 root 3. 6 can cancel 6. At the end of the day, I'm going to have 3 all over 3 times 1, 3. Root 3 times root 3. Root 3 times root 3 is root 9. Root 9 is 3. At the end of the day, I get 1. So look at the board. Irrespective of the approach that we try to apply, you realize that we get the same answer. So in mathematics, we don't have a particular approach. Just use the approach that you think is appropriate and you are convenient with, without manipulation. I must emphasize, without manipulation. If you follow the step and the rules very well, you are going to get the answer. I try to follow different approach now. You realize that we got the same answer. So we don't have a particular approach in mathematics. You just know the rules, that the rules of that topic, follow it religiously. You can use any approach. At the end of the day, we are going to meet at the same point. So we have our meeting point. Okay, that is that about the first question. So let's take another one. Let's look at another question. Let's take another question. Let's take one more question on this. Then we'll move to somebody talked about matrices, but I think the only matrices you have there is just it's only 2 by 2 that you have in your syllabus. So we are not going to do more than 2 by 2. It's only 2 by 2 that you have. I'm very sure. If you check the new general mathematics of man, so it's only 2 by 2 that you have. It's only 2 by 2 that you have. So we only talk about 2 by 2 matrices. So this is let's consider one more question. Under Surds, the one that involves rationalization, then we can move to another topic. Let me just look for a question that okay, I've seen one here. So this question, look at this question now. Look at this question. It's objective question. 1999 question 10, where we have if k square root of 28 is objective question plus square root of 63 minus square root of 7 is equal to 0. The question says that we should find k. Find k. We have to find k here. So how do we do it here? Look at this question now. This is k, is a constant. This is 27. So what can we do about this? No, we can say this is k, square root of what is 27? Now let's say this. So let me establish this fact. If you have a square root of a particular digit, if you want to break it down under sort, you make sure that one of the factor must be a perfect square. Perfect square is in the sense that look at this 28. You know 4 times 7 is 28. So 4 times 7 is 28. 7 is not a perfect square because square root of 7 is not a whole number, but square of 7 is a whole number. But 4 is a perfect square. Square root of 4 is 2. Square of 4 is 16. So if you want to break any number down, you want to break it down under sort, you will make sure that one of the factor that you want to reduce must be a perfect square. That is the law. Okay? Plus, in this case also, we have 63. Square root of 63. That 63 can be 9 times 7. In this case now, 9 is a perfect square because square root of 9 is 3. Square of 9 is 81. But 7 is not a perfect square. Then minus square root of 7 equal to 0. Okay? In this case now, I can write this and say this is, what is square root of 4 is 2. 2k, we are going to have 2k square root of 7 plus square root of 9 is 3. I'll take this to 3 square root of 7 is still the same thing, minus square root of 7 equal to 0. That's what we are going to have. Okay? That's what we are going to have. 3 square root of 7 minus, though in this case now, we have 2k square root of 7. 3 minus 1, there is 1 here, imaginary 1, don't put it. 3 minus 1 is 2. So I'm going to have it to be plus 2 square root of 7 is equal to 0. Okay? That's what we are going to get. When you do this, that's what we're going to get. Then from here now, I will say 2k square root of 7. I can transfer this to the other side. Minus 2 square root of 7. Okay? So divide both sides by 2 square root of 7. Divide both sides by 2 square root of 7. This will cancel this. This will cancel this. This will cancel this. So k will be equal to minus 1. So k will be equal to minus 1. So in this case, k is minus 1. Okay? Here is minus 28. If this is 63, so this is 3. Here we are going to have 2 root 7. 3 root 7, that will be 2 root 7. That's what we are going to get. Okay, that's what we are going to get. So then we can have questions that involve rationalization. I'm trying to look for one that involve rationalization. So we can have questions that involve rationalization. So let me generate one question that involves rationalization because of the conjugate. So you know what to do. So this will be the last question, another sort, where we have simplify 1 all over square root of 3 minus square root of 2. If you have this type of question, what do? You cannot solve this directly. Then if you want to solve this now, we are going to multiply both the numerator and the denominator by the conjugate of this denominator. If I want to simplify this, this is what I will do. I will say this multiplied by square root of 3 plus square root of 2. Square root of 3 plus square root of 2. Conjugate simply means if this minus, it will be plus. So this is fractional, so that involves fraction. So the denominator, you multiply both the numerator and the denominator by the conjugate of this denominator. So if you now open up, if you multiply at the numerator, you have square root of 3 plus square root of 2 all over. Now, let me expand, but I'll tell you the trick that you can use without stress. If you expand this now, this will multiply the 2. You're going to have 3 minus square root of 6. Then you have minus square root of 6 minus 2. That's what we are going to get. So this will cancel this. At the end of the day, you have square root of 3 plus square root of 2 all over 3 minus 2 is 1. So the final answer is square root of 3 plus square root of 2. That's what you are going to get. But when you use a sort to multiply its conjugate, you don't need to stress yourself. The only thing that is required here is that square the first one, square root of 3 squared, minus, you square the second value, square root of 2 squared. Square root cancel square root, square root cancel square root, you just have 3 minus 1. 3 minus 2, which is 1. So that is what you should know. When you use a sort to multiply its conjugate, we are going to get a whole number. So I would love to stop here. I would love to stop on sort. So I would love to stop on Surds. So I'll stop on Surds. So maybe we take another question. People talk about matrices.
All right, so what we are going to do is this. Let's just go on matrices now, and let's see. Some of us, I can see a lot of us raising questions on matrices. A lot of us raising questions on matrices, and we quickly want to look at questions on matrices now. So let's see some questions on matrices. Like we said, matrices used to be one of the topic. So don't worry, we are still on with you. So this is one in further mathematics before, which people used to call advanced mathematics before. So, but we'll just look at it. Okay, so let's look at it now. When you look at matrices on its own, the word matrices, the matrix, I don't want to go into that now because this is singular. Then when it comes to matrices, that is the word, that is the plural. Do we get that now? So, but that's not where we are going because this is more or less as a revision class. We just want to see where are those areas that question can come out. There are different areas. We have different types of matrices. Of course, we want to look at the addition. We want to look at subtraction. Then, if time permits us, we move on to multiplication. We move on to the multiplication. Then if time permits us, we'll move on to inverse as well. So, but like I said, there are different types of matrices. We have the order. The order depends on whatever the order they give you. But just as we have rightly said that for us at our level in general mathematics, we may likely not go beyond 2 by 2 matrices. And that's what we'll just treat at now. So if you look at the addition, let's say a matrix is usually denoted by capital letter. They don't use it, they don't make use of what is it called, small letter. So let us assume we have 2, 1, 3, 4. So these types of matrices is 2 by 2. This is the order of these matrices is 2 by 2. Then they can also give us another matrices called matrices what? Matrices B. That can be let's say 1, 4, 0, 3. So this one now, this is matrices of 2 by 2. When we look at this now, this is order 2 by 2. This is also order what? order 2 by 2. By the time we get to multiplication, we are going to explain some things to you there. So for the case of this one now, they can give you different things. They can say find number one, they can say find a plus b. They can say we should find a plus b. They can say we should find a minus what? Minus b. They can as well tell us to what? To find a multiplied by b. That's number 3. We'll do all these 3 together. Then they can also do what we call a kind of scalar matrices. A scalar matrices in form of, they can also to find 2a. That's number 4. So we'll quickly do all this without wasting much of our time. So I'll clean this side. Or let me continue under here. Can we see it? If you move under here, okay. So let me write the number. Let me write the values here. A matrices A is 2, 3, 1, and 4. And matrices B is 1, 4, 0, and what? And 3. And we are asked to find the addition, multiplication, and subtraction. So let me clean this. I still have the question with me here. So I will leave the question here. So the first one we want to find is A plus B. So finding the matrices. Okay. So let me bring down the questions, or let me come down. Of course, we know the question. So we want to find matrices A plus B. So the matrices A is 2, 1, 3, 4. That is 2 row, 2 what? 2 column. Of course, if you have to go to what you mean by rows and column, you know what it means by row. It's just like when you go on your assembly ground and they ask you to be on a row. So it means the row is the what? The row is the horizontal. While the other one, the column is the vertical. So we don't want to go into that because we have no business with that one here. So plus 1, 4, 0, 3. So here now, what you are going to do is that which one look like these two here? You know, if I pick this one out, this one look like this. So that means I'm adding 2 plus what? Plus 1. If I pick this one, 3 plus 4. Can we see that now? Then I move on here. Plus 1, 4. So this is addition. So we add number together. So I pick row with row. Another method you can, when you pick this row with this row, you see that when I put them under each other, this one will come under this, and this 4 will come under this. This 0 will come under 3, this 0 will come under 1, and this 3 will come under 4. So when I add these two together now, 2 plus 1, that will give me 3. 3 plus 4, that will give me 7. 1 plus 0, that will give me 1. 4 plus 3, that will give me what? 7. So it means my matrices A plus B is going to give me 3, 7, 1, 7. Is that clear? So with that, I've been able to do addition. Any questions on that? Okay, so let's move on to subtraction. So let's move on to subtraction now. Just like the same approach, I'll just clean what we have here and move on to this now, because we want to find A minus what? A minus B. That is the difference between matrices A and matrices B. So just like what I said, pick this. If I pick 2, 3, 1, 4. So 2, 3, 1, 4. So 2 with what? With 1. So 2 minus 1. Then when I move to the other side, 3 minus 4. Then when I come here, 1 minus 0. Then 4 minus 3. So let me subtract this. Find the difference between this. Difference between 2 and 1, that one is what? 1. Difference between these, great, that will give us minus 1. Don't forget, because 3 minus 1, you have 3 and you are owing 4, that is minus 1. Then this one, that will give us 1. Then take this away from this, that will give us 1. So the difference between A and B is just 1 minus 1, 1 and what? And 1. Is that clear? So that is that on what? On subtraction. So let's move on to multiplication now. Let's move on to multiplication, and that is where majority of our students used to have some challenges. But I'm going to tell you that there are short ways to do that. You don't need to constitute any fear once you are asked to multiply. That's matrices A. This is matrices B. 1, 0, 4, 3. Okay? So we are asked to multiply A multiplied by B. So you put the two beside each other. 2, 1, 3, 4. Can we see that? One of my teachers used to tell me something. He said, make use of 7. 7, 7 is the multiplication of matrices. So I'm going to make use of the 7. So can you see now? So if you are writing 7, it's just like when you are writing 7, you know that is the 7. So you are picking the first row with this what? With the first column. And don't forget, that is why when you are multiplying matrices, unfortunately, at this our level, we are only saddle, we only work on 2 by 2 matrices. But when it gets to a stage whereby you are having like 3 by 4, let me quickly tell us, in case for those of us that may come across this in JAM or in UTME, let's say we have matrices of 2 by 3 or that 2 by 3. The only matrices that you can use to multiply this again can only be 3 by what? Either 3 by 1 or 3 by 2. Meaning, once this cancel this, your final answer will be 2 by what? 2 by 1. Do we get that now? That's example 1. Another matrices that you can multiply successfully is, let's say I have 3 by 1. Another matrices you can use to multiply this again can only be 1 by either 1 by 4 or 1 by anything. Let's say 1 by 4. That's the only matrices that can multiply again. And at the end of the day, you get 3 by what? 3 by 4. So, for instance now, this one is 2 by 2 matrices. This one we have here is 2 by 2 matrices. 2 by 2 matrices. So, what will be our result? That means these two will cancel each other. Then we have 2 by 2. So, that means our answer must be 2 by 2. I'm just showing us that so that we know how you can predict the order of your order of the matrices, the answer to the order of that matrices, especially in the areas of multiplication. So for this now, you are making use of that 7. That is the first row with the first column. First row with the first column. So first row with the first column, 2 multiplied by 1. You leave it in that way. Plus the second one, which is what? 3 multiplied by 0. You are done with this first one. Do you get that now? So let's move on to the second one. The second one will just be what? The same thing. You are applying 7 again. The first row and the what? And the second column now. You are picking the first row and the what? And the first column. So you are picking the first row with the second column now, which should be 2 multiplied by 4 plus 3 multiplied by 3. If there's any confusion here, let me know in the chat. If there's any confusion here, let us know in the chat. No confusion. So that means it is clear. So what I'm trying to say, what I'm trying to tell us is that when you want to multiply any matrices, so what you just have to do is that what? You pick the first row, multiply by the first column. You move on to the first row, multiply by second column. Is that clear now? It's clear. Someone is saying we don't understand. So let me take it again. Let me take that again. So I'll start all over again for the multiplication. I know the addition and subtraction is clear. And that's why we said we'll clarify these issues of multiplication. So let's see the multiplication. Like we said, when you pick the first one is 2 multiply 2, 1. That's the first column. The second column is 3 what? 3, 4. So with the second one, the first column is 1, 0, and the second column is what? 4, 3. The rules is that you pick the first row, multiply by the first column of the second matrices. So the first row multiplied by the first column. So the first row now, the first element there is what? Is 2. 2 multiplied by 1 plus 3 multiplied by 0. I hope that is clear now. So first row with the first column. First row with the first column. Is that clear? Okay.
If that is clear now, so let's move on to the first row with the second column. First row with the second column. First row is 2, 3. The second column is 4, 7. 4, 3. So that is 2 multiplied by 4 plus 3 multiplied by 3. So with this, you are done with the first row of the answer. So you move on to the second row. You repeat the same thing for the second word. For the second row too. That's this multiplied by the first column. That is 4, 1, multiplied by what? Multiplied by 1 plus 4 multiplied by 0. Now move on to the second one too. Second one, 1 multiplied by 4 again plus what again? Good. You can see 1 multiplied by 4 and this multiplied by this. That is 4 multiplied by 3. Is that clear now? Now when you look at something is playing out here. Something is playing out here. Look at this. 2, 1, 3, 4. 2, 1, 3, 4. Can we see that now? 1, 1, 0, 0. 4, 4, 3, 3. Where do you see that? Great. So that means you are using this first word, the first matrices. Everything in this first matrices is being repeated on the first column. Can you see that now? I will apply another method, but let's complete this one first. So you now tell me the best method now. So now let's complete this now. 2 multiplied by 1, which will give us 2. Which will give us 2. Can we see that? Yes, I want to make sure you can see my board now. I want to sum this now. So 2 plus 2 multiplied by 1, that is 2 plus 3 multiplied by 0, 0. 1 multiplied by 1, 1 plus 4 multiplied by 0, 0. I'm completing that. 2 multiplied by 4, 8 plus 3 multiplied by 3, 9. 1 multiplied by 4, 4 plus 4 multiplied by 3, which is what? 12. So let's complete this now. Let's complete. Can we complete it here? Under. It's going to work. So 2 plus 0, that will give me 0. 1 plus 0, that will give me what? Sorry, 2 plus 0, that will give me 2. 1 plus 0, that will give me what? 1. 8 plus 9, that is going to give me 17. 4 plus this, that is going to give me what? 16. And you can now see that what? When we multiply 2 by 2 matrices with 2 by 2 matrices, it is giving us what? 2 by 2. If this is clear, can you let us know in the comment section before we move on to the scalar matrices? So what we are going to do is that we are trying to do this just to do the revision for you and to let us know how we care for you. We don't have any other way to support you than to do this kind of a thing for you. So far so good. We have been on this for close to 4 hours now. And at the end of this class, you can go and watch the recording just to do practice and check. And there are other videos under this channel you can see. I've also add my own channel to this, which is Adewale Kayode online class. I've also solved some past questions as well. You can also go to Tambua online class. You see different past questions they have solved. And Esem online math class. All these people, we have come together to do this, to package this for you under the Mathematical Association of Nigeria. So let's move on to the last one. Can we move on to the last one? Which I talk about the scalar matrices. So let me clean this now to go on to the scalar matrices. The scalar matrices can also be in it can come in any form. Then thereafter, I will allow Dr. Ufaote to rest a little bit. Probably, if you can still see how we can still do 1 hour more, maybe between 9 and 10. So because we have to go on break, we have been on this for the past 4 hours. So let us see something like on the scalar matrices now. On the scalar matrices, let's say we have 2a plus 3b. Can we see this? They can say 2a plus 3b. That's number 1. Let me call this one number 1 for you. Question can come on that because we wanted to see if you can see, if you can check past question to see this, they can say 3b plus, or let's say 3b minus 5a. Can we have it in that way? Okay, let's have it in that way, and let's see this. So what we mean by scalar matrices is that the complete matrices, you are going to use it to multiply what you have here. So that means for the number 1 now, it's going to be 2 into the A. The matrices A is 2, 3, 1, 4 plus 3 into 1, 4, 0, 3. So what do you mean by scalar matrices? You are using that element to multiply everything we have inside the matrices. So for this now, we are going to have 2 multiplied by 2, which should give us 4. 2 multiplied by 3, which should give us what? 1, 2, 4, 8. Complete. Plus 3 multiplied by 1, 3. 3 multiplied by 4. Great. That will give us 12. 3 multiplied by 0, 0. 3 multiplied by 3, 9. So you can see that it has now turned to, what? To addition now. It has turned from scalar matrices, it's now turned to what? To addition. So we are going to multiply this, all this together now. So I'm going to multiply this. I'm going to jump step now, because by now I know you understand what we mean by addition of the matrices. So 4 plus 4. Sorry. You are adding this one and this one, and that will give us what? 4 plus 3, 7. 6 plus 12, 18. 2 plus 0, 2. 8 plus 9, 17. And that is the answer to this number 1. Is that clear now? So what we'll do is that every other thing you need, like I said, will be shared under the comment section. We'll share both the transpose. We have videos on transpose of the matrices. We have videos on inverse of the matrices. We are going to share them under this video. So on the final note, we are going to show you more channels you can go to get more questions to support you in preparing for tomorrow examination. Like we said, tomorrow examination, I'm going to write it here. Toidel online class. So I'm going to write all of them here for you to see. We'll have Toidel online class. So we have this on Facebook. We have this on Facebook. On YouTube, we also have Toidel online class, and that is the channel we are using to broadcast this. So you can also go to Facebook again. Okay, so let's give you, we have Adewale Kayode online class. I know some people will say, but we thought you teach mathematics in Ijebu. True, we teach mathematics in Ijebu. We also teach mathematics in English, because you know you are going to write your examination in English, and that is why we are doing this in English for you. So we are only using the Ijebu to break the language barrier for people in an underserved community, or people that did not really understand English fluently. So you can see that on Facebook. You can also see that on what? On YouTube. So go to YouTube, you see Adewale Kayode online class. Online class, you see that there. Then you can also go to Facebook again. You see Esemnofu